Today we're going to go through the TShark basics, which is a part of the SOC Level 1 pathway of TryHackMe, and it's a continuation of the network security and traffic analysis module. We did a lot of videos on Wireshark, which was a big piece, and a lot of people love those things, and TShark was recently added to the SOC Level 1 pathway in this specific module because it's basically the command line interface version of Wireshark. So I'm really excited about this one. I think we're going to get to learn a lot of good things together. And yeah, that's basically it. So let's talk a little bit about what this whole thing is. So as we already mentioned, Wireshark is the developer that created TShark, and it's a command line tool. So the Wireshark original tool is a GUI tool. It has a graphic user interface. There's a lot of point and click stuff and drag and drop and all those things that are visually pleasing, but sometimes it can be kind of slow, which is why command line tools are always a really good idea if you're dealing with speed requirements and you need to respond in a timely fashion. And if you're comfortable with the command line, then you end up loving these tools much more, simply because of the fact that they're faster. Now, as they say, it has most of the features of Wireshark, so I'm expecting that some of the features are going to be missing, but we're going to find out exactly what those features are together. Some of the learning objectives are to learn to filter traffic with TShark, implement Wireshark filters inside of TShark, and expand and automate packet sniffing with TShark. So these are a few things that actually I don't think are even available with the GUI graphic interface of Wireshark. So I'm really excited to see what those are all about, and I've already launched the virtual machine that's attached to this, so it should be nice and easy as we move forward. They do recommend the network fundamentals room and the Wireshark modules, and I've done the entire network fundamentals pathway as well, so these check marks imply that these are all done. There should be some decent videos on this, although I feel like this was actually way too much of a beginner module, and I may not have done this because there's a lot of things in here that you can find by simple Googling. So if you don't know what networking is, or if you don't know what a LAN is, or if you don't know what the OSI model is, and packets and frames, all those things, if you don't know what those things are, you might want to look into it. I think you can actually find some videos on this channel. It would be at the very beginning of this channel starting, so I'm not exactly sure if I have these or not. But this one for sure, the Wireshark basics room, I know for a fact that I have. So if you actually look up Wireshark on the channel, you will definitely find those videos. So that being said, let's actually get this going. Alright, so these are some useful hints for us as we go down the command line path together. All of these things are basic command line tools. So grep, cut, unique, nl, those are all basic Linux command line tools. Capinfos, I think, is actually something that I've never actually used before. It's a program that provides details of a specified capture file. It is suggested to view the summary of the capture file before starting an investigation. So this is not specific to TShark. This seems to be a general command that's available inside of the Linux command line. Sed is the stream editor, and awk is a scripting language that helps pattern search and processing. So these are all actual command line tools and utilities inside of Linux. And grep helps you search through plain text data. Cut cuts parts of the lines from a specified data source. Unique filters repeated lines and values and gives you only the unique values that exist in something, so you don't get repetitions of the same value over and over and over again. You only see all the unique values. And NL views the number of shown lines, so it just shows you how many lines that you got in there. So that is it as far as the tools that we got, these little hints that we got. So the first thing that they want us to do over here is to answer these questions based on the demo pcap file that's on the desktop right here under our exercise files right here. So one of the things that I'm going to do is I'm going to open up this in a new window so that we can look at it easier. And I'm just going to open this up on a separate window so that we get a chance to go back and forth with this. So I'm just going to actually literally move this into my other monitor so that I can see it while we're going through this room together, and then from there we'll be able to get some good exercises, and it'll display well on the screen as well. So let's go back over here and let's go full screen with this, and let's do some command line stuff. All right, typically when I get into a command line, I just want to know where my working directory is. I want to know what's inside of my working directory, and we notice that we have the desktop as the very first thing. So we want to go into our desktop and find those exercise files, which they are right there. And now inside of this, we have one pcap file, which is the demo pcap file. So we're going to run this capinfos command with the demo pcap ng file. And with this information, we should be able to find the answers that we're looking for. So the first thing that they're looking for is the, what is the value? It's the ripe MD 160 value. So the ripe MD 160, which is this thing, and this is right here. I feel like this is a hash value. So versus MD5, this is probably MD 160. So let's go into this thing right here and let's do that. There we go. Okay, that's the first answer of the exercise. Okay, cool. So that one was fairly quick, fairly easy. Let's move on to the next one. All right, so now the command line tools that actually directly apply to TShark. These are the actual commands and options that apply directly to TShark. So the first one is the -H, and it's usually the help page. So with most tools, -H takes you to the help menu for TShark. -V for this case is the version info of VShark. Capital D, capital D, gives you the available sniffing interfaces, and -I helps you choose an interface. So you can do -I1 or -I ENS55, which I'm assuming is the name of the actual interface in this particular case. And then no parameter by itself, if you just type TShark and press enter, it starts sniffing traffic very similar to what TCP dump does. So -V gives us the version info. Sniffing is sudo tshark -d, and it shows you the various interfaces that you can scan, and then from there you would choose your option. So no interface argument is an alias for I1. So if you did -I1, would probably give you that. And in this particular case, if you wanted to do just sniffing by itself, you would do tshark, and then it starts capturing on ENS5, which is that original interface. So what is the installed version of the TShark that we have? And then list the available interfaces. What is the number of available interfaces that we have? So let's do those specific commands together real quick. All right, first we're going to do tshark v, whoops, like that, and we should get the version info of tshark real quick, or I guess not real quick. Let's see how long that takes to populate. Okay, that took a few seconds, a little bit longer than I wanted it to, but we got it. So 3.2.3, I believe, is the version. So let's see, 3.2.3 is the version. There we go. And what is the number of available interfaces given our VM? So tshark -D would give us that information. And we got 12. Wow. We got a bunch of stuff over here. So 12 interfaces would be our answer for that. Excellent. So, all right, moving on to the next piece. The main parameters of TShark is what we're mostly interested in. And these are things like -R, which would be reading the pcap file. -C would give you a count, so a packet count after a certain number. So if you do stop capturing, filtering, reading 10 packets, for example, it would be tshark C10. And then the W would be the write or the output function. So if you sniff traffic using tshark and then you do W sample capture, it's going to write on this new capture file the traffic that it sniffs inside of that command. Verbose is capital V in this case. So lowercase v gives you the version info, capital V gives you a verbose version of the sniff, which most likely gives you just more details. That's typically what verbose does. It just gives you more details and it gives you more of an output. And then we have Q in silent mode, so it suppresses the packet output on the terminal and it doesn't show you everything on the terminal. I guess it just kind of just starts capturing and it runs in the background in quiet mode and silent mode. And X gives you the bytes of the packet. So it packs the packet details in hexadecimal format and ASCII, ASC dump for each packet. So it gives you a lot of the details of the hexadecimal and AC details inside of the output or displayed onto the screen. So based on what I've gathered about a lot of different command line tools, you can combine a lot of these things together. So you could do -R and then add the -X to give you hexadecimal output based on what it's reading inside the pcap file, right? So TShark R demo pcap will read that pcap file and it'll go all the way and give you all the details. If you do TShark R demo pcap C2, it'll count and it'll just give you the first 2 packet captures and it stops after the first 2. If you could do TShark R demo pcap count 1 and then W on the demo pcap, it'll write it to a new pcap file for you. So it'll read this one, take the first packet and then write that into a new pcap file, and then they're just running ls to see that there's an actual demo pcap, and then you can read the demo pcap and you'll see that it only gives you that one entry. Packet bytes, so read the packets right here, you see all of that. If you read it with X, as we mentioned already, it gives you the packet bytes, so the hexadecimal and the AC format of everything that's inside of that packet and all of the traffic that's been captured. If we do R count 1, it still gives you that one count, that one packet. If you do R count 1 in verbose mode, you'll notice that instead of just it giving you these basic lines right here, you get a lot of more information that comes out of that one single packet that we're displaying. Including the length of the packet, any flags that have been turned on, time to live 128, the type of protocol that it's running, the source IP address, the destination IP address, a lot of great information instead of just giving you this kind of basic information right here, where if you know how to read these things, you'll know that this is the source IP and this will be the destination IP and that's the protocol, that would be the port, etc., or the source port, destination port, right? If you know how to read these things, you can kind of decipher what that means. In this particular case, it literally tells you source IP is this, destination IP is this, and it'll probably keep telling you what the source port is and what the destination port is. So it helps you read the contents of the packet in a much easier way, which is why verbose mode is typically, if I know that something offers verbose mode, I will usually just run it in verbose mode because it gives so much more details about it and it's just super freaking useful. And this is a comparison to the TShark CLI versus the Wireshark GUI. So if we were to open a single packet in Wireshark and open up the Internet Protocol portion of it and the TCP transmission control protocol portion of it, it's very similar to what you would see inside of the command line with TShark if you do verbose, right? So if you don't do verbose, you're not going to get that information. But if you do verbose, it actually gives you all of the details that you would see if you were actually looking at it inside of Wireshark and just breaking down each one of these portions individually themselves. So it's very, very helpful and probably, hopefully, much quicker than running Wireshark and the GUI platform. So now what we're going to do is we're going to read the the demo pcap file with TShark and find the TCP flags that are in the 29th packet, and then the ACK value of the 25th packet, and the window size value of the 9th packet. So as you can imagine, we're going to be looking at the count parameter. So we're going to count until the 29th packet just so we can see that 29th packet, and we're going to see the TCP flag. So we're going to do the verbose output for this one. Same thing, we're going to do verbose output and we're going to do verbose output in all of those just so we can get all of these details. But we're using the count parameter just so we can get the 29th, 25th, and the 9th, right? So I could technically just print all of the 29 and then go up to 25 and then go up to 9, but we want to get good at writing these commands, so we're going to do multiple versions of that, right? So here's what we got over here, and I'm going to clear my screen and we're going to start from the very top. So we're going to do TShark R pcap, or excuse me, let's see, what is it? I think, what was the name of the file? Demo, there we go, demo pcap, there we go. We're doing that, and we're going to do verbose, and then we're going to see, and we're going to count to 29. So it's going to give us the 29th. This very last piece would be the 29th packet. So if I go up here, it should be the 29th packet. So let's see if we can actually get that information. There we go. So frame 29, and it gives us all the information about it. So the question that they had was, what do we need from the 29th? We need the assigned TCP flags in the 29th packet. So let me find those flags. And we find that under the transmission control protocol portion of this thing. And if you come down here for flags, you'll see inside the parentheses, it gives you 2 flags for this particular packet, which is the, I believe that's the push and the acknowledgement packet. So PSH and ACH would be our answers. So we're going to do PSH, ACK, and PSH. All right, there we go. That's the right answer. Now the 25th packet. So what's the ACK value of the 25th packet? So we're going to go back over here. And essentially what I'm going to do is I'm just going to press up, and it's going to bring me the very last command. And I'm just going to count to 25 and get the very last one. And now we want the ACK value of this particular packet. And this is actually under transmission control protocol as well. So if I kind of pull this out a little bit, it's a little bit easier to see it at the top right here, because you can see it right at the very top where it says ACK 12421. But then there's also a section right here where it says acknowledgement number, which is 12421. So both are the same exact value. So we're going to go back over here, and then, whoops, what was it? So it was 12421. And there we go. That's that answer. So what is the window size value of the 9th packet? So we're just going to press up. It's going to bring us the command again, and we're going to do count to 9, and we're going to get the 9th value. And right there, so window size value 9660 for that one. That one showed up right on the screen, and we got it. So there is our answers for the main parameters. So pretty straightforward, pretty useful if you know how to use some of those basic parameters, basic command options right there. So that's what we got so far. Let's move on to the next one for capture conditions. Real quick before we move on to task number 5, I wanted to tell you about Hackaholics Anonymous. This is our membership community that's available on this channel, and I really think that you'll get a lot of value from it. There are a lot of different perks that are available. There are 4 tiers of the memberships that are available, and if you haven't checked it out already, I think you would be surprised pleasantly about how amazing Hackaholics Anonymous can be, and I would just love to see you in our Discord chats and in our membership community. So if you haven't checked it out already, definitely check it out. All right, let's move on to task number 5. We already know that TShark has the ability to capture traffic and sniff traffic, so there are some parameters that we can use to actually make that happen. So define capture conditions for a single run or loop, stop after completing the condition, also known as auto stop. So that's what this whole thing, all of these things are going to do. So the first one is -A. And the duration would be to sniff the traffic and stop after X seconds, create a new file, and write output to it. So you do TShark W to write to this test pcap, and then the A would be auto stop for the duration to be 1. So after a certain number of seconds, I guess, I don't know if the 1 is 1 minute, or maybe 1 packet has been captured. Or this could be 1 second. Probably I think the X represents the 1 second. So it captures for 1 second, I would assume. File size in this particular case. So define the maximum capture size after, and then stop after reaching X file size. So write to the test pcap, all of this is going to be the same. And then the file size is going to be 10. So when you reach 10 kilobytes, stop writing and stop running. Files would be the maximum number of output files, stop after X files. So write to the test pcap, file size 10, and then files 3. So that's actually really useful to know. So it's going to create 3 files for you. I guess it would be test 1, test 2, something like that. And then the file size of each file is going to be 10 kilobytes. And then we have the ring buffer control option. Define capture conditions for multiple runs or loops. It could be an infinite loop, right? So the duration in this particular would be 1. So sniff the traffic for 1 second, create a new file, and write output to it. I guess B1 would mean that it just runs for a second and reruns. I'm not exactly sure what that means. This one would be file size is 10. So essentially everything is the same with the exception that the option is B, and it would run multiple runs or multiple loops, creating an infinite loop. And that part is a little bit confusing to me. So let's see what the hint says right here. So TShark supports combining auto stop with the ring buffer. You can combine the parameters according to your needs. Use the infinite loop option carefully. Remember, you must use at least one auto stop parameter to stop the infinite loop. Okay, that kind of makes sense, because if I guess if you don't use the auto stop, it's just going to keep running and probably create a bunch of files inside of your computer. So that probably is not a good idea. In this case, it's going to start sniffing the traffic and stop after 2 seconds, and then save the dump into 5 files, each being 5 kilobytes. So it's going to write into auto demo pcap, and then the duration is going to be 2 seconds. File size is going to be 5, and then files would be 5, and then it's just, that's it. It's running and it's capturing, and then it's going to create these various pcap files for you, 1, 2, 3, 4, 5, right? So this one is all using the A auto stop parameter. We don't have an example of the B infinite loop parameter, but I guess you technically don't need it. Like if you know exactly how many files you want, how many replicas or duplicates of the files you want, how many various captures you want, I don't think you need to create a loop, because technically you could just say, you know, do all of this and then stop at file 10. Or do all of this and stop at file 100, right? And it would still work, and it would keep creating various files for you until it's done. So I would just rely on the auto stop function, not to create an infinite loop, unless you really know what you're doing. And I don't, so I don't want to do anything crazy here and make my VM crash in this particular case. So what we have is which parameter can help analysts to create a continuous capture dump, and that would be the B. Whoops, it needs to be a -B, and that's the continuous infinite loop. And can we combine auto stop and ring buffer? You can indeed. That's all the questions that they had for us. So I guess we don't need to run any capture exercises right now. Maybe we'll do it in the future, but for now we just needed to know what these capture conditions were. So let us move on to the next piece here, which is the packet filtering options, capturing versus display. There are 2 dimensions of packet filtering in TShark. There's the live dimension, which is for capturing, and then post capture, which would be the displaying of those 2 various instances, I guess. So you would either capture or you would display, right? These 2 dimensions can be filtered with 2 different approaches using a predefined syntax or Berkeley packet filters. I remember these guys. These are technology used in certain computer operating systems for programs that need to, among other things, analyze network traffic. BPF supports filtering packets, allowing its user space to supply a filter program that specifies which packets it wants to receive. Got it. TShark supports both. You can use Wireshark filters and BPF to filter traffic. As mentioned earlier, it's a command line version of Wireshark, so we will need to use different filters for capturing and filtering packets. A quick recap from Wireshark packet operations room. So you have the capture filters, which is a live filtering option. It's to save only a specific part of the traffic, and it's set before capturing the traffic, and it's not changeable during the live capture. Display filters are post capture, and just like the name implies, they filter the display after the packets have been captured, so that you only see the number of visible packets that you're interested in, which is changeable during the investigation. So you can change your display filters as you're going through your investigation. Capture filters are set once, and then the capture begins, and then you can't change it during that capture. Capture filters are used to have a specific type of traffic in the capture file rather than having everything. They have limited filtering features, and the purpose is to implement a scope by range, protocol, and direction of filtering. This might sound like bulk raw filtering, but it still provides organized capture files with reasonable file size. The display filters investigate the capture files in depth without modifying the packet. The F parameter stands for the capture filters, same as the BPF syntax and Wireshark's capture filters. The Y, capital Y, parameter display filters, same as the display filters in Wireshark. So the packet operations video for Wireshark will show you a lot about the principles of packet filtering, either in the capture filters or the display filters. And that is, again, part of the videos that we recorded for Wireshark, and those are actually available on this channel as well. So let's get to these things. It says which parameter is used to set capture filters, and as we can see on the screen, it is the F parameter, and display filters are used with the Y parameter. So easy does it, easy money. Moving on to the next one, filtering options for the capture filters. All right, we have these two sources. So there's the pcap filter from wireshark.org, and then there's a GitLab repository as well for a bunch of filters that are available for Wireshark and their capture filters. So these are external sources outside of TryHackMe, but they are actually very useful, and you can probably just find those by Googling as well. So if you do Wireshark capture filters on Google, you will most likely find those same exact links as well. The type of the qualifier for the capture filters here looks like this. So we have the filtering a host. So you have host, net, port, and port range would be your options. Filtering a host would be TShark F, and then you put all of this in quotes where you say host and then the IP address. Filtering a network range, so same thing. The TShark F part is going to be exactly the same with each one, and then you put all of the options inside of quotations, as you can see. For a network, you would say net, and then you do the first 3 series inside of the subnet, and then you leave that last one as a 0, and you do a -24. This is where the networking understanding actually helps a lot. And so what it does is that it looks at everything inside of this range, with the only thing that changes is this portion at the end right here, and it goes from 0 to 255 from what I remember. So it'll give you 10, 10, 10, 1, 10, 10, 10, 2, 10, 10, 10, 3, 10, 10, 10, all the way up to 255. Filtering a port would be port 80. So it just looks at everything inside of that port 80. And then port range would be the initial port dash the ending port. So the beginning and then the ending separated by a hyphen or a dash. So that is what the capture for these various ranges are. So host, network, port, and then port range. And then we have the direction. So you have a source and a destination. So if you want to filter the source address, you would say source host this, and it would look at everything that has this IP address as the source. And then if you want that IP address as the destination, you would say destination host that. So you can imply to which amount of traffic you capture based on who you want the source host to be and who you want the destination source to be. And then we have the target protocol. So you can have the ARP, address resolution protocol. You can have the Ethernet, ICMP, IP, IP6, TCP, UDP. All of those things can be as your target protocol. And I guess all you got to do is just put it inside the quotes, right? So for TCP, you would just do TCP inside the quotes. You could probably do UDP inside the quotes as well. If you want a MAC address specifically, you would do Ethernet, because Ethernet addresses are the MAC addresses. So you would do Ether and then the host, and then you provide the MAC address that you want to be tracked and filtered. You can also filter protocols with IP protocol numbers assigned by IANA. So as a standard organization that oversees global IP address allocation, autonomous system number allocation, root zone management in the DNS, media types, and other internet protocol related symbols and internet numbers. And then we have the IP protocol 1, for example, where you would be IP proto 1, which in this case would be ICMP. Then we have the assigned internet protocol numbers, which is actually probably a very useful tool here, that it will tell us what all of these various things are and how they are assigned, because these are not the port numbers, right? So these are the actual protocol numbers that have been assigned to these things. So TCP is 6, and let's see what else we can find here. UDP is 17. The ones that I recognize, the ones that are the ones that I would probably be displaying here. IPv6 is 41. IPv6 route, IPv6 fragmented, all of these things, most of these I actually don't recognize. So it goes to show you that I need to study up on my networking as well. But this is a tool from IANA, the Internet Assigned Numbers Authority. And these are the guys that have these assigned decimal numbers for these protocol versions or protocol IDs, I guess. I think that's what that would be. But yeah, that's it. That's how you can filter by protocol as you capture your data. So there is something called the Terminator. The Terminator terminal instance to have a split screen view in a single terminal. And the Terminator will help you craft and sniff packets using a single terminal interface. Now run the Terminator command and follow the instructions using the new terminal instance. And so that's what it looks like right here. So very interesting. So I actually want to do this. This is not something that I have done before, so I'm really excited about doing this. So what I'm gonna do is I'm going to open this on a second screen, and then we're actually gonna run it and we're gonna capture it and see what we can get over here. So let's go over here and we're going to zoom in a little bit. Okay, so let's clear this up. We're gonna do Terminator. Sick, interesting. Okay, let me zoom out and get that back onto the screen like so. All right, so this is our Terminator instance of the shell. Very, very cool. So we have the top, we have the bottom portion. So in the top portion, it's saying to scan any given IP. So I guess I'm just going to use the IP that has been assigned to us. So we'll do TShark F, and then we'll do host 10.10.140.251, which is the IP that I've been assigned. And so that's going to start capturing, and it is capturing. And then we're going to go over here, and we're going to do a curl v 10.10.140.251 and run that. And we got that. And then what do I do? Right, being comfortable with this, you can use the table to do practice TShark filters. So I'm going to stop this running because it seems like it's just running. And I wonder, I should have probably done like an output so we can try to capture that instance as well to see what we can get. There should be some kind of a HTTP request that has been done using our curl command inside all of this data. And I wonder if I can even use that. Can I search through this? I can't search through it. So this is interesting though. Like I've never done this before. I've never used Terminator. So this is actually really interesting that we can do this. I just have never done it. So that one is kind of cool. Okay. So what they're telling us to do is we should be able to use these capture filters. So being comfortable with the command line and TShark filters requires time and practice. You can use the below table to practice the capture filter. So capturing traffic to or from a specified host, traffic generation with curl. This command sends a default HTTP query to a specified address, for example, tryhackme.com. TShark capture filter for a host would be fhost. Oh, you can also do a domain name, so you don't necessarily have to do an IP address. That's actually good to know. IP filtering involves traffic to or from a specified port, and we can use the netcat tool to create noise on specific ports. Traffic generation with netcat. Netcat in this case creates a verbose connection to this particular piece with a timeout of 5 seconds. So it creates a netcat connection to this specific IP address on port 4444, and it will do a 5-second interval, right, where it provides the details to this particular IP from the IP address that you're on, and it will do a interval of 5-second data delivery. The TShark capture filter for that IP address would again run at the same time. So this would happen first, and then you run capturing on TShark for that specific IP so that you can see what's going on. So we can do a variety of these things to track with TShark. Another one is traffic generation with netcat on the port IP, so or the port address, excuse me. Port address is also not the right word. Port number probably is the right word. So in this particular case, we were capturing on the host. In this case, we're capturing on that specific port, which will probably be better because there shouldn't be too many traffic connections being made on this random port number. And then we have protocol filtering. So netcat UDP is the U flag right here. And again, same thing, every 5 seconds is going to send it, and then you would filter with the UDP filter to capture that. So run the commands from the above terminator terminals on the target machine and answer these questions. What is the number of packets with SYN bytes? So let's see. So I'm actually going to rerun basically the commands that we had over here. But the one thing that I want to do is I want to create an output file so that I can try to analyze the traffic a little bit easier. And I think that would probably be the best way that we can do this. So it doesn't specify which various commands to run inside of the terminator. It just says to run what we see inside of the above terminal. Run the above terminator terminals or above terminator terminals on the target machine. Yeah, so that's the only thing that it shows right here. So in this particular case, I'm going to run this again, same exact thing on the host, but then I'm just going to do a write command, and I'm going to put it inside of the test pcap file just so we can see what the output is going to look like. And then down here, we're just going to rerun our curl command, and you can see it's already in the thousands over here. And the curl command has been run again, so it's all good. So now I can just stop this thing from running, and there should now be a pcap file, a test pcap file. We have that. So we'll just go over here, and what I'm going to do in this case, if I close that, oh, it closes the terminator altogether. But I do have a test pcap file now. So what I can do in this case, I can search through my test pcap file and try to pull these various SYN packets, essentially, is what we're trying to do. And we want to see how many of those things there are. So I'm going to combine a few of the command line hints that we got at the very beginning while we were grepping, and we're trying to find specific unique values, so on and so forth, right? So I'm going to run a few different commands to see if I can actually find the data that we're looking for. So let's see what we can find. Okay, so after actually running this a few times and trying to search through that document, I actually found out that I think I'm supposed to be running them on this IP address instead of the actual IP address of the virtual machine that we've been given, which is this IP address. That's what I've been scanning this whole time. So what I'm going to do, I'm going to run Terminator again, and I'm going to run these various commands, these two commands again, and instead I'm just going to use the 10.10.10.10 IP address instead of the one that is actually belonging to this specific machine. So hopefully this time I'll actually be able to get some SYN packets that I can count, because I grepped through it and I couldn't even find the SYN packets, the number of the SYN packets. So let's see, let's try that one more time. Yeah, and this time it actually wasn't constantly capturing traffic either. It actually just started and nothing was happening until I ran the curl command. And when I ran the curl command, it showed me the various SYN packets. So here's what I'm going to do. I'm actually going to stop this, and I'm going to rerun it again, and I'm going to write to a test1 pcap, so a new pcap file. I'm going to run that, and it's going to capture it, and it's going to run it, and it will run the curl command one more time. And then there we go. We got 12 entries, as you can see, and then it just stopped running, so there's no more entries being captured. So I can stop that one and then go back over here, and we can stop this thing right here. And now we can do TShark to read our test1 pcap, and then from there we can grep for SYN, and let's see what we get. We get 2 instants that show up right away. I wonder if that's actually the right answer. So let's do that. These aren't this is the page. I'm super zoomed in here. So let's see if 2 is the right answer. Yeah, it is the, okay, great. Great. So what is the number of packets sent to the IP address 1010.10.10? So we want the IP address to be destination 1010.10.10. So that's what we're going to look for. So let's read through this one more time. Instead, what we're going to do now is, instead of gripping SYN, we're just going to read through it. And then what we're looking for is the 1010.10.10 IP address to be the destination IP. So this is the source, and then after the question mark would be the destination IP. So we have 1 is the destination IP, 2, 3, 4, 5, 6, and 7. I got 7. So let's try 7. Very good. And what is the number of packets with ACK bytes? So I have this on the screen already, so I'm just going to do that. So I got 1, 2, 3, 4, 5, 6, 7, and 8. I got 8 with ACK bytes. So let's try that. All right, cool. There we go. The biggest thing was I actually had to run it against 1010.10.10 instead of running it against my own virtual machine IP that's been assigned to me in this case. So, all right, cool. Very good. That one's in the bag. And moving on to the very last exercise. And display filters are now going to be the ones that we're going to look at. And we do have the Wireshark reference document that shows you a lot about the various display filters that are available in Wireshark. And it's very similar to the packet operations room and just the Wireshark GUI in general. For example, if you do ip.addr, so IP address, it'll show you anything that has to do with the source or destination address being that IP. If you do IP source, in this case, it'll show you only the traffic that has to do with that being the source, and an IP destination, only the traffic that has to do with that being the destination. You can also do a network range, very similar to what we had in the capture, where you just leave off the last segment and subnet, and in this particular case leave a 0 and just do /24, and it shows you everything that has to do with this intro, and then the rest of it, any extension of that specific IP address. And same thing for protocols, so TCP port 80, TCP source port or TCP destination port 80, all of those things still work. We can do HTTP as a protocol. So instead of DNS, for example, or ICMP, you can just search for an individual protocol and just show those. And then if you want to look for a response code and only the successful responses that came in, which would be HTTP 200 response code, all of that is possible as well. And then filtering DNS packets as well, right? So DNS query type 1, needing to know what it actually means. So you need to know what all the query types are and how they relate to Wireshark queries, but then you can also do that as well where you do a DNS query type 1 or a variety of other DNS query types that are available. So there's a lot more options. Obviously, if you look at this document, there's a lot of options that are available here for filtering through displays or display filters through Wireshark. So that one is a big one, and there's a lot of options that are available. So what we're going to do in this case is we're going to use the demo pcap file to test these display filters, and we're going to search for a variety of various queries. So IP address in this case, and it will show you the number of queries. I don't know if this is all of them. It seems like there was only 2 that has to do with that. And then this one for the HTTP queries that are available inside of that specific file, HTTP new line, or number line, I think not new line, number line. So it shows you the number of the line that query exists on inside of the packet. So this one's on line 4, this one's on line 18, 27, 38, so on and so forth. So we're going to use the demo pcap file to answer these last set of questions here. So for the first question, it says, what's the number of packets with a specific IP address that starts with that 65? And I think the NL actually counts the number of lines. So I don't think it shows you the number of the line that's on there, because inherently it just shows you that. but I do believe that it counts the number of lines. So if I do the demo pcap reading, and then if we do a capital Y, and in this case we're going to do ip.addr equals the IP address that they want from us, which is in this case 65A228.223, and then we do that, and then we just pipe that into NL to give us the number of the lines. And so from what I understand, this is actually 34 entries. So that's what that does, and it gives you the various numbers of the lines that those things are on inside of the actual log file itself, inside of the capture file itself. But we have 34 counted, so that should be our answer. So let's try that. Yeah, it is. Excellent. Okay, so that is how it works. So now it says, what is the number of packets with a TCP port of 3371? So pretty much same concept, except now we're going to look for the TCP port 3371. Oh, I forgot to count it, so let's do that and do that. And now we have 7, so let's try that here. Excellent. So what is the number of packets with this IP address as a source address? So very, very similar to what we did, except now we're just going to change it to searching for the source address. There we go, and we got 20 of those, so we're going to run that over here, and there we go. Now rerun the previous query and look at the output. What is the packet number of the duplicate packet? So the same thing, and look at the output now. What is the packet number of the duplicate packet? So we have TCP dupe acknowledgement. I believe that's the one, so that's packet 17, and I can't see anything else that actually has a duplicate packet in it. So 17 would be the one. That would be my guess. Oh, it's not. Okay, so let's see what else we got. Actually, I was totally right. I'm reading the wrong thing. So this is the count. This is not the packet number. So this is the duplicate packet. That's the right one. But it's not 17. It's actually 37 is the packet number. That is my bad. I was misreading this thing entirely. Okay, so there we go. That's the right answer. And that's it. That's it for our exercises for the introduction to TShark. All right, if you found this video useful and if you would like to get more videos like this one, I definitely do encourage you to check out our channel and like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. There's a lot of great stuff on here. There's the original SOC Level 1 playlist that has all the original videos on it, and then there's all the additions that we're going to be making as we go along and update that playlist together. So if you want to get the rest of the stuff on TShark and the rest of the stuff on all the missing videos for SOC Level 1, I do encourage you to like, subscribe, and turn on the notification bell. Or if you just want to get anything else about cybersecurity and ethical hacking, I think you would like this channel. So hopefully I will see you in our comment section, because we have a very live comment section. There's a lot of people that drop a lot of comments and they ask a lot of questions, and I am very responsive. And if you actually have a really good question, I will make a video dedicated just to your question. So on top of liking, subscribing, and turning on that bell, I would recommend that you drop a comment if you have any questions, because I am responsive and I do make videos if you have a really good question. So hopefully I'll see you in the comment section. And I do gotta remind you about Hackaholics Anonymous, because it is going to be the premier YouTube community for security professionals and hackers, mainly because of the fact that I really want it to be, and I put a lot of work into this community, and there's a lot of perks that are attached to it. So we have the downloads that are exclusive to our members, we have the content exclusive to them, we have the bug bounties that we go in on together to make money, there's the Python automations that we give away at the end of every single month, there's the Discord chat, there's the discount on merch, there's so much stuff that's available, and there's 4 tiers of memberships that are available, just to kind of give you options for you to choose from in case one doesn't work for you and you want something else. So if you haven't checked it out already, I really recommend you check it out. It's on our homepage. You can watch the video, or if you click on this read more button, it'll open it up in a new window and you can read through the description that also has a breakdown of all the perks that are available. And I would love to see you in the Discord chats, and I would love to see you in a part of the Hackaholics Anonymous membership community. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I'll see you in the next video later. In our last video, we went through the TShark basics room and we covered the fundamentals of TShark by focusing on how it operates and how you use it to investigate traffic captures. We also went through display filters and capture filters. In this room, we're going to go advanced features, and we're going to be focusing on translating the Wireshark GUI features to the TShark CLI. And you'll see exactly how you can actually get all of the functionalities of the GUI inside of your command line interface, which is really awesome. I've already started our virtual machine and we are ready to go. This video is based on the TShark CLI wireless features room that is a part of the SOC Level 1 pathway of TryHackMe. And as a part of this pathway, we have the network security and traffic analysis module. And a lot of these we recorded the first time that we went through the SOC Level 1 rooms, but they added some rooms recently that I was notified by from our community. And so we're going to be going through all of these rooms that I have not done so we can have videos for them. And then at the very end of this thing, we have this massive challenge that's available to us as well. So very excited about going through all of this, and hopefully you will also find it useful. All right, one of the key Wireshark features is the statistics menu that you get access to that gives you a lot of really great information about the traffic that you've captured and about specific packets and, dare I say, transactions that are going on inside of that network. And the three important points that we want to talk about or keep in mind as we go through this is that these options are applied to every packet that is in the scope of your capture, unless there's a display filter that is provided to prevent those packets from showing up. Most of the commands that are seen that we're going to go through are CLI versions of the Wireshark feature that's discussed in the Wireshark packets operations room, which, by the way, all of those videos are also available on this channel. As long as you just search for Wireshark on our channel homepage, you'll be able to find all of those videos. And finally, TShark explains the parameters used at the beginning of the output line. So for example, if you use the PHS option, you'll view the protocol hierarchy. Once you use that command, the results will start with packet hierarchy statistics header. And this is just one of the parameters that we're going to be covering through. So the parameters are as such. So color, specifically -- color, is going to show a similar Wireshark-like colorized output, which I'm actually excited to see because I wonder what it looks like on a command line. Then we have the -z, which is giving us the statistics. So if you do -z help, of course, you'll get the help menu for that specific statistics option. And then the sample usage would be TShark -z filter. And every time that we filter the statistics, packets are shown first, then the statistics that are provided for those packets. So you can suppress packets and focus on the statistics by using the Q parameter. And then we can also limit our output, so on and so forth. So this, I guess, is exactly what it looks like as a colorized output. This looks identical to the Wireshark interface. This is actually really freaking cool. So this is basically TShark R, so reading the color pcap file and then just using the color option just so we can see what it looks like colorized. This is freaking amazing. It literally looks identical to the Wireshark GUI, so that's pretty cool. And then we have the statistics protocol hierarchy. So if we do R demo pcap, so reading the demo pcap again, and then we just do -z to get our statistics, and then you have IO, PHS, and then -q. So IO, in this particular case, I think it might be the interface, and then PHS would be the protocol hierarchy. So for example, protocol hierarchy statistics, you have the filter, Ethernet, IP, TCP, so on and so forth, and then the frames that are associated with them, and that's basically it. So we're going to go through all of those options just to answer the questions that we have in this room. So we're definitely going to get to use all of these things in advance. And then we have our demo pcap, so to actually read the file again, and then we're doing -z. And then this time we've added UDP because we want to see the UDP packets connected to our network capture. So the filter right here shows UDP. Over here, there was no filter that was attached to it. So the filter actually shows UDP, and then it gives you the information about the packets as far as the protocol hierarchy itself is concerned. And then packet length tree. So -z, and then we have plen for packet length, and then we have tree, And tree, I think, is just mostly showing the organized version of it. So the packet length tree view helps analysts to overview the general distribution of packets by size in a tree view. It allows analysts to detect anomalously big and small packets at a glance, and then you use that to view the packet lengths tree. So this is exactly what it looks like. It's just this very clean output compared to what we see over here. Very, very clean output that you have over here, including all of these the titles, I guess you could say column titles or field titles, so to speak, with the various values that are attached to it. So very, very cool, very useful. Oh, we actually have more stuff at the end here. So we have the burst rate, the burst start. This is very similar to what's available inside of Wireshark in general. So in the first video, they said that there are some capabilities that we won't get from Wireshark, but so far it seems like we actually get everything that is available inside of Wireshark as well. We have our statistics endpoints that allow us to view the unique endpoints that are available to us. So it shows you the number of packets associated with each endpoint. If you're familiar with Wireshark, you should know, or Wireshark, not Fireshark, you should know that endpoints can be viewed in multiple formats. TShark supports multiple source filtering options for endpoint identification. So if we use Z endpoints IP and then Q, we will be able to see that we can get Ethernet, we can get the IPv4 address, IPv6 address, TCP, UDP, WLAN, all of that good shit. Or excuse my French, good stuff. We have TShark reading the demo packet, using Z for statistics, and then now we want to see endpoints, IP, and then you see all of these pieces right here. So very, very useful information. And finally, we got, I don't know if this is actually finally, I may have been premature with that. So we have conversations. Conversations is basically what happens across multiple IP addresses, and you get to see the back and forth between those two IP addresses. And you have this right here. So these arrows are talking about there's a back and forth conversation happening. It's not just going to this, or it's not just coming from this. It's literally back and forth conversation that's happening. So you get to see the frames, the bytes, the start, and let's see. I think this has been kind of compressed, so you don't get to see the full amount of data that's going on over here, because these things, this portion of it is kind of like messing with our menu that we have over here. But I think it would start with the forward and the backward option to be able to go back and forth, and you have the total relative duration. So total relative duration, I would assume that's what we're seeing over here, because it's a little bit congested. But essentially a conversation is the back and forth conversation that happens between two IP addresses. So most likely you will see more than one communication going instead of just a single packet going from one to the other. You'll see a connection of packets, a series of packets going back and forth between those two IP addresses. And then we have expert info, which is very similar to comments that are available, as well as descriptions and notes and a lot of great things that you can actually use for analysis of the packets and the traffic that you got. So Z expert, and that's basically how you would get your expert info. And then so we have notes that are attached to this one in particular, and then we have the chats that are attached to this as well, and they are grouped and they have various protocols that are attached to them, for example HTTP, and then there's a summary description of what is going on for whatever packet or let's say series of packets that it is that you're looking at. So now we're going to use the write demo pcap to answer the questions that we got, and hopefully we'll be able to pull it off in a without any errors, so to speak. So what's the byte value of this, what is the packet length, and what is the summary of the expert info, demo pcap to answer the following questions right here. And that is essentially what we got. So just like every other video that we do, I'm going to open this up in a full screen format just so it's easy for you to see. And then from here, I'm going to open this up in a new window, and then I'm going to drag this into my second monitor so I can still follow the instructions that we got, but just make sure that you actually get everything that you need on screen. So let me make sure that this is all good, and then we'll get started. All right, so first we got to find our exercise file. So we are, let's see, we are in our home Ubuntu, and then we have the desktop, and they said that our files are on our desktop. So we're going to go and find them, and they are inside of the exercise files folder. So there are our files. So very good. And let me just ls one more time just so we can see it. So we got that. Okay, so what we need, I think the first one that we're going to be looking at is the write demo. So this is the file that we're going to be looking at. And the first question is the byte value of the TCP protocol. And so based on what we've learned so far, there are two ways that we can do this. So number one, we need to actually read the file. So that's the first portion of this. And then what we're going to do is we're going to do the Z for statistics. And then I can do this, right? So I could do IOPHS for the protocol hierarchy. And I want to see what it looks like without Q actually. So let's see what that actually looks like. Okay, I mean, the output of this is not that bad. So I wonder what it looks like with Q. So let's do that part and let's actually add Q. Let's see what that looks like. Oh, you know what? It's quiet. That's what it is. So quiet doesn't show you the contents of the packet. You just get to see the statistics. So this is our content of the packet. There's literally, or the content of the pcap file, and there's this one packet, and then based on that there was, you know, this information. So if you do it in quiet mode, then you just get the information without the contents of the packet, which is very useful. Okay, so all right, now I understand what they meant when they said when you look at statistics it'll still read the file as well as that. Okay, so the question is asking what's the value of the bytes for TCP, and it's right down here. So it's 62. So I'm gonna go down here, and I'm already zoomed in, so hopefully you won't mind kind of a little bit of blurriness, because there's two forms of zoom that I can do. It's the one where I manually zoom back and forth, but then when I manually zoom back and forth, I can also do this double click on my mouse and it goes like super zoomed in. And usually I just do the double click because it keeps everything nice and crisp. But when we're inside of the view for the virtual machine, I can't do the double click because I'm no longer inside a Mac OS. I'm inside of a Linux machine technically. And my magic mouse doesn't work with my double click. So I have to manually do the zoom. But that's so irrelevant. You probably didn't even need to hear all that, but whatever, now you know. Okay, so that was the first question that we had, which is the byte value of the TCP protocol. I want to show you actually the second way that we can also do this, because the version that we looked at right here is the IOPHS. So instead of doing that, we could actually technically just pull up information about the TCP protocol technically by filtering for TCP. So I could literally just do this and pull up that entire thing, and as my options at the end right here, I could just add the TCP like that, and it'll still, I mean, it still gives me the same exact information as last time. I just have the TCP filter on here, and if there was more traffic that was inside of this file, there would be a lot more data that would be printed onto the screen if I didn't use TCP. They would give me all of the other options for XML and HTTP and yada yada yada, so a bunch of other stuff. But in this particular case, there was literally only these 3 data points, so it just worked. But if you wanted to, you could do TCP, you could do UDP, you could filter for a variety of different protocols. So that was our question, and now we can move on to the next question, which is in which packet lengths row is our packet listed? So in which packet lengths row is our packet listed? It's like a funny question. But we know that there is also a packet lengths option for this. So if we would just read our pcap file and then do it with, of course, statistics for this whole exercise, we're going to be doing that. So there was the plen for packet lengths, and then there's tree to just kind of show you the organized version of it. And then from there, we would just do it in quiet mode. And now we have all of this data, and we want the, since we have technically just one packet, yeah, I would say it's literally this one packet right here. So since we only have the one packet, it would be in the, what is it, 40 to 79? Was that be the, that's the answer, right? 40 to 79 probably? Okay, cool, yeah, there we go. Next one is, what is the summary of the expert info? So let's go get some expert info for our file, and we can do that using this very, very fancy Let me actually clear the screen real quick for you. We can do it by reading the file, of course, and then we would do expert after we put Z, and then just do that bad boy in quiet mode. And there we go. So connection established request SYN. And what was the question again? What is the summary of the expert info? So this is our summary. So I wonder if I need to do that entire. Oh, actually, no, you know what? It goes to the second line here. So that's the summary. So we copy that, go over here, voila, boom, and there it goes. And now we're going to do the demo pcap to answer the question, list the communications, which is conversations, and what is the IP address that exists in all IPv4 communications. So we're going to do a combination of queries that we're going to use. So we're going to do conversations, and then we're going to do IP, and that should just pull up all of the IPv4 conversations that we have. So let's run that, and what is it? It's called the demo pcap. So let's clear this thing up, and we're going to read the demo pcap, and we're going to do Z and conversation IP and do it in quiet mode. And now I need to see which IP address shows up in everything, and it seems to be this guy right here, 145.254.160.237 shows up in all the communications. So boom. What do you mean? Oh, defanged format, my bad. So defanged format. So if you already don't know, let's pull away from our screen here just so we can go into CyberChef real quick and get a defanged version of that thing. And we do that, and then we have the output, so we just got to do the defang real quick. So go right here, do defang IP address, drop that, and boom, look at that. You see the defanged IP, copy that, and then go back here, one more, paste that, blow. There we go, defanged version of the IP address. And we are officially done with our first task over here. So let us move on to the next one, which is the statistics part 2. This series of filters that we're going to be using is also covered in the packet operations room for Wireshark, or the packet operations video for Wireshark. And I mean, there's a lot of filters for just for statistics, right? So I feel like hopefully we're gonna go through all the other features that are available on Wireshark as well. But as you can tell, the statistics can get you a lot of detailed information. And so one of them, as we continue here, are the IPv4, IPv6 packets. Having protocol statistics helps analysts to overview packet distribution according to the protocol type. You can filter the available protocol types and view the details using p-type, protocol type, and tree. So using quiet as the parameter, just so you can see the stats, this is what you would see over here. And this should swipe a little bit more as well. So there we go. So the maximum value for the rate, the percentage, burst rate, and burst start. So that would be this, that would be this would be this, maximum value. Apparently, there's no minimum value here, so we're all good. And then you see the protocol types all together is 43, but then there's 41 TCP and 2 UDP. So that's going to give you the IPv4, IPv6 volume, so to speak, of how many protocol types actually exist. And if there was HTTP, if it was ICMP, all of those things would also be listed here. In this particular case, we just have these two. Moving on to seeing everything in a single view, especially when you're working with large captures, and a single command can help you. You can filter all IP addresses using the parameters given below. So you can get the IP hosts in a tree view. You can get IPv6 hosts in a tree view. And in this case, they're just looking at the IPv4, and this is what it looks like. So all of the addresses are 43. This address showed up 43 times. This address showed up 34 times, and so on and so forth. So all IP addresses in this particular case were 43 unique IP addresses from what I've gathered, right? So this is, I believe, filter all the IP addresses using the parameters given below. So yeah, that is what this option shows us. And then we now have the tree view for IP source destination and an IPv6 source destination. So in this case, IPv4 source destination, and this is what it gives you, right? Source IPv4 addresses, there are 43 of them. This is this, and then IPv4 destination addresses, 43 of them, so on and so forth. And it gives you the amount of times that they show up. And then we have destinations in general. I think that's what they're saying, right? So you will need to focus on outgoing traffic to spot the used services and ports. You can filter all outgoing traffic by using parameters given below. So destinations and ports. Yeah, so this is going to give us destinations and ports in a tree view, and then IPv6 destinations and ports in a tree view. And so you see this right here. Destinations and ports altogether are 43. And then you have this particular one. What is the port? Where's the port? Let me see where we can get that data, because for some reason it's missing. So let me see. Hold on one second. Oh, I see. So this is the IP address, and then this is the port for the one that showed up for this guy, I guess. So all of these ports, from what I understand, show up under this IP address for TCP ports. And then you have 3372, 3371, and then UDP ports 3009. And then we move on to this IP address, and it gives us all of the ports for that one. And so there are 22 TCP ports altogether. 18 of them are this, 4 of them are that, which adds up to 22 for this portion. And then we have UDP 1. Okay, that makes sense. So it's all dry. I feel like it's the view that we're in. I want to say that it shouldn't look like this, but we'll see how it goes. Do the same thing with DNS. So you can actually get DNS packets summarized in the available info. And as such, we have the total packets, R code, which is no error, op code, which is a standard query. These are our DNS codes that are available in this case. HTTP, same thing, right? So HTTP tree, HTTP2 tree, HTTP2. That's interesting. I wonder what that actually is, because they're not saying HTTPS. So I wonder what that actually means. So you summarizing load distribution, request packet status info. This is what you would get over here. And then you have HTTP load distribution for service or server, maybe service or server. Then you have the requests view, and then you have the requests and responses view, which would be used with the sequence acronym. This is just REQ for requests, and then this one is server for load distribution, HTTP, HTTP2. So what we have is just a regular HTTP view. You have the total number of packets, the response packets, 200 anything would be success. So the actual stat itself or the response itself was 200, and there were 2 of those. So this is all right here. And then broken, 0, 300 redirection, 0. We're missing the rest of them, but there should be 2 other packets because we only see the 2 for the success packets, and the rest of the data is as such. So now we're going to use the demo pcap file to answer these questions. Which IP address has 7 appearances? Enter the answer in defanged format. So we got to use CyberChef. And then which destination address percentage? What is the destination address percentage of the previous address? Which IP address constitutes 2.33% of the destination addresses in defanged format? And what is the average queue name length value? So all of that good jazz we're about to find from our interface here. So let's zoom in on this thing and let's get some query writing happening. All right, the first question was which IP has 7 appearances. They didn't mention whether it's source or destination. So what we're going to do is we're going to get all of the appearances of all of the IPs. So we're going to be reading the demo pcap file. We're going to read it with the statistics view. And what we want is IP hosts. And then we want the tree view. And of course, we want it to be in quiet format. And so this is what we got. And 7 instances would be this guy right here. So we're going to copy this thing, and then what we're going to do, let me see if I can go here and just scroll up and paste that, and then scroll back down and copy that, and that would be our answer in defanged format. Boom, there it goes. What is the destination address percentage of the previous IP. So this is this destination address percentage. Okay, all right, there we go. That's what we need to do now. We need to change this for destination address. So let me first find, actually, all right, here we go. TShark, whoops, typing on the wrong screen. Look at me, losing my mind here. All right, here we go. Okay, and -1 is incorrect, so we want to do -q. There we go. All right, so these are all of our destination addresses, all in all. And actually, I think this one is also showing me destination ports. So I wonder, yeah, I wonder if I can show, yes, I can. Yes, I can. Okay, so I'm going to clear up the screen. All right, so to find our destination list, we're going to read, again, this file. We're going to read it in statistics format. And what we want is the, I believe it was IP SRC for source, and then DST, not DEST, DST for destination, and we want it in tree in quiet format. So there we go. Now we have all the destination IPv4 addresses. And what the question was, destination of the previous IP. So 5999 destination percentage would be, yeah. So it's this 6.98, including the percent, I guess, right? 6.98%. Yeah, there we go. And which IP has 2.33%, which is this guy right here. So we're going to take this one. Oh, Control C doesn't work. Or I guess Command C doesn't work. Go here, paste that, and then come down here, copy that, and boom. Cool. And what is the average QName length value? Okay, what is the query that's going to give us that QName length value? Okay, so from what I've gathered in our little hint was that it is a DNS value. So we are going to read our pcap, and we're going to use DNS tree, and then we're going to use it in Q. And so now what we want is the QName length value. So let's go up here and see where that actually falls in for our average. And where is that information? Ah, there we go. So this is the QName, and so I want to say that this is the average. So let's see how this actually plays out. So we have the topic and the item, and then you have the count, which is the next one. The average would be the third one. So topic or the item, the count would be this, the average, and no, this is the percentage. So what is going on? I think I need to zoom out here and expand on this window. Yeah, see, now this gives us a little bit more organized of the data. So average is actually this field, and so now if we go down here, we'll be able to find the average of the QName length. So let's go find that thing. There we go, QName length 29.00. There it is. Sweet. All right, we are officially done with this particular task. So let us now move on to streams, objects, and credentials. Before we move on, I gotta give a shout out to the Hackaholics Anonymous membership community, the premier membership community that is inside of YouTube for security professionals and hackers. And I really love this community. The people that are in there are very supportive of each other in the Discord chats and just in general, really, really cool people. We have some really great perks that are attached to this community for all of the 4 tiers. I highly recommend you check it out. And a big thing is I really would love it if you actually watched the video to see what the perks are, or you click on this little read more and then you go in the description of the video and then you read the description down here just so you can see what the perks are that are attached to each level. It's very important to me that you understand what you're getting yourself into, and I don't want anybody to have buyer's remorse. I don't want anybody to tell me that I didn't tell them anything, because I've actually gotten people to tell me that, and I'm like, yo, the description is literally right here, bro. Everything that you would get is actually listed inside of this. So it would mean a lot to me for you to check this out. and I think you'll get a lot of value out of it. So it might be biased, and it might be me believing that I'm drunk on my own punch or whatever it is. But if nothing else, I think it's good for you to know that this exists, and if you are ready for the future reference, you can bookmark it so that you can check it out for later. All right, that's all I got to say about this. Let's continue with the rest of our video. All right, now we're getting into some of the more nitty-gritty stuff. There's a lot of good things that you can get from Wireshark. It's not just random statistics, right? So, and I guess none of those things were actually random. So I don't want to take any steam away or any credit away from what we just discussed so far. But Wireshark, as the reason why it is the most premier free open source network sniffing tool, gets you a lot of good information. Now, a stream is a traffic stream, right? So essentially stream is the best word that I can give you. It's a stream of traffic, right? So it gives you data about a lot of packets. Instead of looking at individual packets or a few series of packets that would be a conversation, it is a stream of packets. So it could be TCP packets in its entirety. It could be UDP packets, it could be HTTP or HTTP2 packets, and you can view them in hexadecimal or AC mode. And then there's the stream number that comes out, and then you have the quiet parameter to keep it quiet for you. So if you do follow and then follow the TCP stream in AC mode, and then you look at 1, which I guess is the stream number, it will give you everything that is relevant to the first stream, and it will show it to you in AC format. So the nodes, which are the IP addresses, node 0 in this case would be the source, and a node 1 would be the destination. You have a GET request that's been made against a web page, and then you have the host being the actual Google syndication. You have the HTTP responses. You have the content type. If there were any payloads or any attachments, you would be able to get to see that. And then, of course, there's a hexadecimal that is also available if you wanted to look at it, but this is what AC looks like. And usually the payload inside of the AC is much bigger. So if you see a large portion of kind of random code like this, there's a lot of good intel in there. And you just gotta kind of build an eye for it, because the first time that I looked at it, I was like, what the am I looking at? This does not make any sense. But eventually, after seeing a few of these and then seeing what is the info that you need from them, which I'm pretty sure they're going to ask us to do for the questions here, after you see a few examples of this, you'll be like, oh, okay, I kind of see how to find the intel in there. So this is an example of what it would look like if you were just looking at a TCP stream, the first one in the list. Then you have export objects. So there are objects that are typically attached to streams. And it could be DICOM, HTTP, IMF, SMB, server message block, TFTP. There's a variety of different protocols that you can export objects from. And objects could be attachments, right? So the query is very simple. Export objects, as the name implies. You choose your protocol that you want, and then the folder that you want to export that file into. So for this particular case, you still read the file. In this case, they didn't use Z for statistics or anything like that. They just said export objects, and they want the HTTP objects to be exported. So there's a space between these two right here, which is very important to understand. There's a export objects, as you see right here, there's a space between them. And then you want the HTTP objects exported. You want them to be exported to a designated folder. And then you want it to be in quiet mode so that it doesn't print all of the data onto the screen. And then when you actually go into that folder, you will be able to see that there are 24 objects that have been exported. And then you get to see what the actual name of the thing is. And usually you'll find shit like this, which is this is all one object. And it's very kind of jargoned up, like congested or whatever, mumbled together. And then we have simple things like the download.html file. You can then look at credentials. See, this is where it gets really interesting, right? So credentials will actually give you, if it hasn't been fully encrypted and hashed out, it'll give you the credentials that are found inside of that traffic or inside of that specific packet. TShark, read the credentials pcap, and then give me the credentials in quiet mode. And this is accompanied by the Z option so that you can look at statistics. And then packet, protocol, username. And then if we actually get clear text traffic, which is, I mean, I can't imagine there would be too many locations, but I've heard other people tell me inside of the world of cybersecurity that, you know, you'd be surprised how much clear text traffic actually still goes back and forth. There's actually a job that I'm currently interviewing for that it's for a pen tester, super excited about it. And they tell me, they're like, yeah, you'd be surprised how many of our clients actually still have clear text traffic that's going through in and out of their network. So I guess it still happens, but I'm like, dude, what are you talking about? How's that even possible? Anyways, use the demo pcap to answer the questions. Follow the UDP stream 0. What is node 0's value? Enter the answer in defanged format. HTTP stream 1, refer value, defanged format. And the credentials pcap to answer what is the total number of detected credentials. So that's what we got. So let's go into our file over here. I'm going to keep it in this view. So hopefully it'll actually be kind of useful for us. But let's see what it ends up looking like. So we'll clear this bad boy up, and these are the files that we want to analyze. Let's zoom in a little bit more here. Let's kind of get this centered. Okay, cool. All right, the first question was we want, gosh, what was it? We're going to be following the UDP stream 0 for the demo pcap file, and we read the file as such. And then we gotta do it in my keyboard, or the computer is falling behind my keyboard because I'm typing so fast. So we're gonna follow this. We're gonna follow UDP, and then we'll do it in ASCII format, and then we're gonna do stream 0 at the very end of this, and then we're gonna make sure that we do it in quiet mode, just to make sure that we have all of the data that we need. And let me make sure I don't mess this up by clicking around too much. And we'll drag this guy a little bit more centered here. Okay, so here's our info. And now the question here states that what is node 0's value? And this is node 0's value. So we're going to copy node 0. We're going to go defang node 0. And we're going to get back node 0 and go and paste it. There we go. Huh. Is that incorrect? Okay, so I think I'm supposed to actually include the port at the end of it as well. So we're going to go copy that, and we're going to defang it, and we're going to copy this, and let's make sure that we actually have, okay, there we go. All right, HTTP stream 1, what is the refer value in defanged format? So same thing for demo pcap. There it is. Oh my God. Look at all this data here. This is insanity. Craziness. So what is the refer value? Let's find the refer. All right, here we go. It's towards the top. And we have refer HTTP, so on and so forth. And it has the download HTML file. So we're going to copy this. And we need to go defang it because this is a big one. So I'm going to zoom out of this right here. And I need to do defang URL as well. So you can have multiple recipes inside of Wireshark, CyberChef. And once you have multiple recipes, it'll just detect whatever the input is and then give you the proper output format, which is in this case a URL. So we're going to get that URL, and we're going to go back here, or not here. We're going to go here, and we're going to paste it, and that should be good. Excellent. And now we're going to look at the credentials pcap to answer the question, what is the total number of detected credentials? So let's go do that. And we're going to read it, very similar to everything else we've done so far. And we're going to look at statistics, and we want credentials, and we want it in quiet format. And let's see how many credentials we get. All right, so we have a lot of credentials, and there's a lot of versions of it. I wonder if I can do count line. I think it was NL to count the lines. So let's see if we can rerun this and actually count the lines so we can see how many of these things there are. Okay, so I was pretty close actually. I need to pipe the response into the NL command so that we can get the number of lines that are counted. And so the big piece is that we're supposed to exclude these three, right? So, and the one at the very end as well, because this is considered a line, that's considered a line. And we want to start from this one actually. So we exclude the top three and then we exclude the one at the very, very bottom. So it should be 75 from what I understand. And there we go. That's what we got. So excellent. So this is a really, really freaking useful option. I really love the fact that you can just learn these things as you go along. So TShark, all that stuff, write the credentials, everything's all good. And then you pipe the results into the NL command so that it will count it for you. And I think you may even be able to use the NL command. Let's see if that is indeed the case without piping it. So if I just do that, it doesn't. So you need to pipe the results into NL, because if you don't, it's going to assume that you're trying to run NL from TShark, and TShark doesn't have NL as an option. So you would run that, and then you would just pipe it at the very end into NL, and then it will give you the results that you need, meaning it will count all of the lines for you. So number line, NL number line, is how you do that. And we got the results, which is 75. So all good here. Let us move to the next portion. Or sometimes you don't exactly know where you're looking. You don't know exactly what you are even looking for specifically. So you want to use something like the contains option or the matches option. And this is again inside of the Wireshark packet operations room. And these are just some of the ways that you can search for data without knowing exactly what you're looking for. So Wireshark has something called the find option. So if you say, just find me anything that contains the word Google, and it'll try to find that information for you. It'll probably be a lot of results, but it'll try to find that information for you. And it search inside of the packet. It'll search inside of the actual packet contents. And it is case sensitive, so that's very important to know. Matches searches for a pattern inside of the packet. It supports regular expressions, really freaking useful. Case insensitive, and in this particular case, complex queries have a margin of error. So if you create a really big regex pattern that's fairly complex, it may not work for you. So if you have not seen the regex video, I would highly recommend you check out the regex video. We may need to create some regex patterns as we go along. So a couple of notes here. The contains and matches operators cannot be used with the fields consisting of integer values. So if there are fields that only have numbers as their values, it's not going to work. It only works for string values, which is alphanumeric, words, etc. Using hexadecimal and regex values instead of AC always has a better chance of a match. So using hexadecimal and regex instead of AC always has a better chance of a match, because as you saw, AC was like a very, there was just randomized letters in there and numbers and things like that, just randomized patterns and characters, and it's kind of hard to make sense of those things. So it would be best if you used hexadecimal and regex instead of AC. So extracting fields would be used with the T fields. So for example, E field name, and then showing the field name E header Y. So for example, you can filter any field by using the field names like below. So you would do T, capital T, fields, and then you want to extract IP source and extract IP destination, and the E header, which would actually show you the header. So in this case, you want TShark to read that file, look at the fields, extract these two for me, and then show me the header. So this is the header in this case, and then count to 5. So basically show me the top 5, but actually show my header, right? So IP source, IP destination, this is all the stuff on the left is IP source, this is all the IP destination. Otherwise it'll just show you this information. There's another trick to this, that like whatever your first option was would be the first column, and then whatever the second option is would be the second column. So if you don't have the header, you could still figure it out if you just understand that whatever your first choice was here would be the first column, this would be the second column. Then we have filtering anything that contains data. So comparison operator can be used. Description would be searching value inside of packets, as we already saw. It's case sensitive, provides similar functionality to the find option. You can find all Apache servers, for example, and you would list all the HTTP packets where the server field contains the Apache keyword. So it would be read the demo pcap file, search for HTTP server contains y Apache. So this is the piece right here. So where's the parameter? I guess it's actually y would be the capital Y would be the specific option that allows you to put whatever you're looking for inside of quotations, and that'll serve as your search function or your contains function. So capital Y, single quote, http.server, which is the actual field name. So you need to know what field name you're looking for, and contains, and then double quotes, Apache. And it's case sensitive, so you need to be aware of that. If it was lowercase a, most likely anything else that has capitalized A in it, it would not show, right? And so you got 38 in this particular case. Read the file again, contains Apache T fields, so all of the stuff that we just did right here, right? So extract the fields for me, etc., etc. So T fields extract the IP source, extract IP destination, extract HTTP server, and show me the header. And so you have IP source, IP destination, HTTP server, source, destination, server, right? So you can combine the queries together to create one giant query, right? Then you have matches. So regular expression patterns, case insensitive, find all .php, .html pages. For example, you could list all HTTP packets where the request method field matches the keywords get or post. So HTTP request matches get or post, and this specifically is a regex type of a pattern. So you do same thing, right? HTTP request method is the actual field name that you're searching for, matches this specific regex pattern, and so you will get all of these results right here, and you actually get the data that is inside of it. So HTTP, get, so on and so forth. And you can combine that with your extraction, where you would get, I want to extract the IP source field, IP destination, the actual request method, and I just want you to give me a header for it. So source, destination, and the request method, right? So useful, really, really freaking useful. And once you get a hang of this, it's very useful. So using the demo pcap file, we're going to answer these questions. What's the HTTP packet number that contains the keyword cafe? And we're probably going to be looking for a capitalized cafe. And filter the packets with get and post requests and extract the packet frame time. What is the first time value that has been found? And we want it looks like the actual date as well as the timestamp inside of it. So that's what we are looking for in this situation. So let's go and zoom back in here and let's do some work. Okay, so I had to do a little bit of Googling to try to find out where that word cafe would actually come in from, and I think it's the HTTP request URI. So let's try it out. So it's going to be TShark read the demo file, and then you're going to look for, so we'll do capital Y, and we're going to do http.request.uri contains cafe, and let me just make sure you actually see the rest of this thing. Contains cafe, and then what we're going to do is we're going to, I guess I'll do all of the fields. I'm kind of like jumbling up a few things together just to hopefully make the results come from. And so we need the frame number, which is what we want, and we also want the http.request.uri. So let's see if this actually works. And it doesn't. Oh, you know what? I need to do case sensitivity. That's the part that I was missing. I need to do case sensitivity. Sounds like I need to take a HR course or something. Nothing still. Okay, so let me see. I'm just gonna modify this in every way that I possibly can and see what I can pull from here. All right, so it seems that I may have overcomplicated this. The biggest part about this that I couldn't find was the essentially the field that I was supposed to be searching through, which I guess is in this case the server is what we're trying to find, and it's going to include cafe. So that part, that was really the hardest part, was like finding the HTTP server. And so now hopefully the rest of this will actually work. So let me just make sure that I have enough of a space. And so we do T, we're going to do fields, we're going to extract the frame number, which is the packet number itself. And then from there, we're going to also extract the HTTP request or the HTTP server portion of it. I just want to make sure that I actually get that data onto the screen. And hopefully, hopefully it actually gives me the information that I need. So let's see if this actually works. And it does. So I mean, it's packet 27, and then cafe portion is the HTTP server name. So 27 would be the field. Yeah, okay, cool. Yeah, the hardest part for me was like, dude, I don't know what exactly I'm supposed to search for in this case. And it's the HTTP server field that we're trying to search for. So there we go. That's it for demo pcap. That's what we were looking for. And now filter the packets with the get and post request, which is matches is what we're going to be using instead of contains, and extract the packet frame time. So that is the next one that we're going to look at, and we're going to try to find the exact time stamp in this particular case. So let's see what we can do here. I'm just going to start the same way. So I'm going to read this thing. I'm going to do my Y, and I'm going to read for the HTTP request method is what we're doing in this case. And it's going to say matches because we want to use a regex expression, and we're going to put it inside of these parentheses, very similar to what we saw in the example itself. So that's what it's going to look like. And you have to close that out with that final single quote. And then we're going to extract the fields, and we're going to extract the, I want to say frame time is what we're extracting. And I think that's it. And then actually let's try to do the E header portion as well. So equals yes, and let's see what we got. So frame time, there you go. Frame time for all of these things, and the first frame time is the one that we're looking for, which is this thing right here. So this full thing is what I'm gonna copy, and let's see if this is actually, hopefully that's right. Okay, nice. Whew, okay, all right, that one's cool. We got it. That was great. Very, very excited about the fact that this actually worked. I spent a good amount of time on those two questions, mostly because of the fact that I had no idea what the freaking thing was that I was looking for, the HTTP server, but a lot of trial and error in that one. So that is a wrap on that one. And finally, let's go through some use cases to extract some information here. When investigating a case, security analysts should know how to extract host names, DNS queries, and user agents to hunt low-hanging fruit after viewing the statistics and creating an investigation plan. The most common 4 use cases for every analyst are demonstrated below. If you want to learn more about this stuff, you can go through the Wireshark traffic analysis room, and that is also a video that already exists on this channel. So extracting host names. So we're gonna read the host names pcap probably. We're gonna do T fields, and then we're gonna extract DHCP option host name. This is like the hardest part. If you don't have a cheat sheet for the various field names, that's the piece that is like a really, really big deal. So going through the Wireshark documentation is what will help you try to find the data that you're actually looking for. So this one is going to help you extract the host names, which is DHCP. In this case, there are a variety of different types of host names or host name fields. So DHCP option host name, and it will print all those for you. DHCP packets specifically, however, the output are hard to manage while multiple duplicate values exist. A skilled analyst should know how to use the native Linux tools to manage and organize command line as shown. So again, same thing. You're going to read through the same thing, and then you're going to pipe it into the AWK awk NF, and then you're going to pipe that into these various things. So sort R unique count, and of course sort R again, and it'll give you all of the unique instances that show up, and give you an actual count for all of them as well. So now the output is organized and ready to process. The logic is shown below. So this is the full query right here. You're looking at the main query itself, and it extracts the hostname values. Awk NF removes any of the empty lines, okay? Sort R recursively sorts before handling all of the values, okay? Unique C shows the unique values but calculates and shows the number of the occurrences. So it actually counts all of the unique values for you. And then sort R again is another sort of this. I mean, it's literally the same command, except you're just piping. So you're piping this into this, then piping that into this, then piping that into this, and then piping that into this. And the final sort process that shows you the output results from the high occurrences to the lowest occurrences. So going from the descending, I want to say, if it's going from highest to lowest, right? So TShark for DNS, same thing. DNS queries, T fields, DNS query name, and then you're going to remove all the blanks, sort, unique count, sort again, and then it goes from highest to lowest. Extract user agents, same thing. Literally the same thing, except you're just looking at the user agents and then extracting the user agent field. And in this case, we were extracting the DNS query name. And those were the lowest hanging fruits, so to speak. So what we're going to do is we're going to use the hostname pcap and the DNS queries pcap and the user agents pcap to answer these last set of questions, and we'll be done with our exercise. So let's make sure that we are zoomed in so you can see everything that's going on over here, and let's get these last series of commands going. All right, so for the host names, we're going to be essentially duplicating exactly what that command was, and then we're looking for the unique number of host names that show up, and then the count of the prus PC, or I don't know what, our prus PC probably. We're gonna get the count and then just find all the unique host names. So I'm gonna type this whole thing out first, and then we're gonna look at all of our results. There you go. So TShark reading the host names, extracting the fields. The field specifically that we're looking for is the DHCP option host name, and then we're going to pipe that into the removing of the duplicates, and then removing of the blanks, my bad, and then sorting, and then unique count, and then sorting again. And so we got that. And so all together now we want, what do we want here? What is the total number of unique host names? And this is actually something that I need to pipe one more time. I think I could do this. Let's see if hopefully it works exactly the way that I would want it to work. So if we just pipe that into the NL, the number line count, there we go. So it actually shows us all of the stuff that we previously had as well, except now it just numbers the lines for us. So we actually have a count of everything that's going on. So the total would actually be 30. So let's run that. And that is true. So what is the total appearance count of the prus PC? So let's try to find that guy at the top right here. And there is 12 count of prus PC. Very good. So very good. That's what we got. Now we're going to look at DNS queries and the total number of queries of the most common DNS query. So total number of queries of the most common DNS query. And let's type this thing out. Let me just clear the screen here. Okay, the highest count over here is 472 of DB Rhodes EDU. So 472, which is a lot. That's a lot by a giant margin of the second one. So now looking at the last set of questions. So user agents, to answer this question, what is the total number of the detected WFuzz user agents? And then the HTTP hostname of the Nmap scans, enter the answer in defanged format. So first and foremost, we're going to read it, and then we're going to see the total number of the detected WFuzz user agents. So let's clear our screen here, and we're going to read the user agents. Okay, here we go. So the WFuzz is saying what is the total number of the detected WFuzz user agents, and what is that? So we got 9 up here, and then it doesn't seem, I don't think there's any more of those except this one. So we have 9 and 3, which is 12 as a total. So let's see if 12 is actually right. And it is. Great. So what is the HTTP hostname of the Nmap scans? So there is going to be an Nmap scan in here somewhere. So we want to find the HTTP hostname of that. And so we got Mozilla scripting https nmap.org. That's the only one that I can see, because everything else is SQL map and so on and so forth. So nmap.host, what is the actual thing, which is right here. So we're going to copy this, and we're going to go and defang it. And this should be our very last answer. So let me zoom out, because usually, oh no, that's actually, I got to do that before I hit conclusion. Oh, that's not it. Okay, let me see. All right, so for this one, we're literally going to repeat the same exact thing, except we're just extracting one other field, which is in this case going to be the HTTP host field, so that we can get that final piece of information. So it's going to still be the user agents file, and we're still going to do the T fields, and we're going to do our HTTP user agent. And then we're also going to extract the, what was it? I think because they gave it to us in our host, in our hint. It's http.host. That's the one that we're going to finalize and extract. And then from here, we're just going to sort through all the data using the parameters that they gave us. And this is super useful. Honestly, I feel like I'm going to refer back to this myself. And then, my God, I can't type. And one final sort at the end. There we go. We got all the data. Great. So now the one that we wanted, and I got to zoom out and I got to kind of organize this a little bit just so I know what I'm looking at here. The one that we wanted was for the one for Nmap. So there we go. Nmap right here. And then we got this piece right here. So I don't know if they want everything including the port, but we're just going to take the port too, and we're going to copy and paste that, and we're going to copy this, and then we're going to come right here, and we're going to paste that. So maybe they don't want the port. So let's take that, and okay, cool. They don't want the port. They just want you to have the IP address without the port. So that is it, I believe. Let's see what the conclusion says, but I think that's it. I think we're done with this lab. Yep, we are officially done with this lab. So congratulations if you hung out all the way to the end. You are an absolute champ, and we're making some really good progress. So we're almost going to be done with this entire pathway. We were done once, but they added more rooms, so we'll probably come back when they add even more rooms, because TryHackMe updates all of their paths so that they can stay current and they can give you as much value and information as possible. So hopefully you got a lot of value out of this one, and you actually kind of tagged along as we went through this whole thing. So super exciting. I really loved it. I hope you did too. If you did get value out of this video, I do encourage that you like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out, because we're still going to be progressing down the SOC Level 1 videos until we wrap that, and then we're going to continue with the SOC Level 2 stuff. And I wish I could be recording all day, but I got projects to work on and a bunch of things, so unfortunately I'm kind of limited to how much recording I can do every single day. But for the most part, there's a lot of videos that are available on this channel. You can come over here and you can click on this little search button right here so that you can search for Wireshark videos and everything else that we got. And of course, drop a comment, because the comment section is one of the most important pieces of this entire thing for me. And there's a lot of questions that come in and I answer them. I respond to literally every single comment that comes in. So I'll answer your question inside the comments. If it's a short question, if it's a big question, then I'll go ahead and create a video in response to your question, and it'll be useful for the rest of our community as well. So They got a lot of good things that are lined up here. We got a lot of good stuff, so there's a lot of content that's already scheduled that I'm very, very excited to actually share with you guys. And as we move along, there's just going to be more and more stuff that's going to come in. And of course, if you have not already checked it out, I would highly encourage you to check out Hackaholics Anonymous, which is the premier YouTube community for security professionals and hackers. There's a lot of great perks that are attached to this community. The community is very supportive of each other and they're very helpful to each other. So I think you will just enjoy being a part of that community. The Discord chats are amazing. We have Python automations that we give away. There's bug bounties that we go on together. There's exclusive content, exclusive downloads. There's discounts on merch. There's live streams with me. There's a lot of good stuff that happens inside of this community. And if you click on read more right here, it'll open this up for you in a full screen. And if you don't want to watch the entire video, which is literally, it's just like 14 minutes long, so it's not a long video, but the video itself describes all of the perks that are attached to it. And as we go through everything that's available inside of these perks, you can get to figure out what you would get. If you don't want to do that, you can just read through the perks in the description down here. And it's very important for me that you understand what is available to you so that you can choose exactly what is right for you. And if you don't want to join right now, bookmark it for the future, save the video, and just make sure that you come back to it whenever you are ready, because Hackaholics Anonymous is my not my pet project, it's my passion project. It's something that I'm super excited about, and I am already dedicating a lot of time and energy to it, and I think you will like it. I think you'll be very impressed if you come into our community and see what we have available for you. So that's all I got to say about that, and we are officially wrapped. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I will see you in the next video. Later. Alright, we are about to use TShark to actually go through an exercise in analyzing a few pcap files, and what we're going to do is we're going to extract some information and compare it with the database inside of VirusTotal to get some full investigations completed and hopefully find the domain that's been marked as malicious and or suspicious. And this represents us with a challenge to investigate some traffic data as a part of the SOC team. And what we're going to do is work with TShark to analyze that captured traffic, those pcap files. And we're going to use the information that we learned from the basics and the CLI Wireshark features rooms for TShark. So if you haven't seen those, I would recommend you actually go through those, because I will do some explanations of the commands that we're going to use, but I'm not going to give a full breakdown of each option of every command. I'm mostly just going to be crafting the queries and the commands to get the results that we need. And I'm going to be referring back and forth from the data that we got while we went through this specific room, because we get a lot of queries and a lot of different options that we can use as we go through this room, and we're going to be using all of these queries and all of these options to answer all of these questions basically. So that's the whole purpose of this video. Alright, the first piece of this is we need to find out where our exercise files are. So we are in home Ubuntu and everything is on the desktop. So I'm going to go on the desktop and I'm going to get into the exercise files folder. And what we're going to be using is that teamwork pcap file for the whole purpose of this thing. So the first question that we had here is, what is the full URL of the malicious suspicious domain address? So what's the full URL of the malicious suspicious domain address? And we're going to be defanging it using CyberChef. So the first query that we're going to do is, first we're going to open up TShark in read mode, which is done with tshark-r. And then this is the file that we're reading. So that part is fairly standard. Now what we need to do is we need to search for a specific field, or at least search for something inside of this file so it doesn't pull everything up for us. And this is the individual field name that we're looking for, because this is going to include all of the URLs basically that was acquired or queried through this specific pcap file and through the traffic that was captured. So you can also use -y to actually use a contains operator where you can look for specific words inside the string, or you can look for matches with regex patterns, so on and so forth. But we don't know what exactly we're looking for or what even the keyword might be. So we're just going to use -y and then we're going to look for that field name. And then what we're going to do is we're going to use -T and then look for all of the fields. So you just do fields and it looks through all of the fields. and then you're going to extract the DNS query name. So this is going to extract specifically that field for us, and then it's going to print it onto the screen. And then if there's something else that you can do is a -E, and then we're going to do headers, and we're going to do =y, so that it actually just prints the header onto the screen for us as well, so that we know that we're looking at the DNS query name. And usually if it's a big enough file, it'll take a few seconds for this thing to read. So let's just wait for this to finish, and then we'll look at the outputs. Okay, so my bad, it's actually not headers, it's header. So I just got to remove that S, and there we go. All right, now we got all of the outputs. So just looking at this, there seems to be something that just looks weird, right? So paypal.com isn't going to have this entire extension to its domain name, and then timesseaways.com, and I really don't want to click on this, so I don't even know what would happen if I clicked on it. But that seems to be really kind of, just from first glance, it seems to be malicious. And then we have toolbarqueries.com, seems to be fine. Witty server, HSD, MD, Comcast.net, Witty server. Yeah, so if I were to bet, if I was a betting man, it would be this specific domain name that I would say is the malicious domain name. So what I'm going to do is I'm going to take this, I'm going to highlight it, I'm going to right click on it, and I'm going to copy this. And then what we need to do is go into CyberChef. So I already have CyberChef open from a previous exercise, and we're going to paste that in there. And then when you do this, there's a portion of this, so there are recipes, right, that are available inside CyberChef. And I have defang IP addresses and defang URL both chosen. And so depending on what I put in my input, my output at the bottom is going to give me the defanged version of that, which is in this case the URL. So that's going to be our specific piece, and we're going to go to our question here, and let's paste this and see if this is right. That is indeed the right answer. So paypal.com, whatever, times CUA, all of that stuff. That is definitely the malicious URL. So now what we're going to do is we're going to do some OSINT, some open source intelligence, and we want to see what the URL of the malicious domain address first submitted to VirusTotal, what that date is. So what we got to do in this case is actually go and open up VirusTotal. So I'll just open up one more link at the bottom right here. I already have VirusTotal, and then I'm going to search for this URL, scan for that, and press enter. And so we have one out of the 96 queries that showed up that is a criminal IP address vendor analysis, that is a phishing website, and first submission under details shows us is this piece right here. So I'm going to take this whole thing. I don't know if the UTC actually needs to be in there, but we're just going to take that with us anyways. And we're going to go here. I think it does need to be in there. And there we go. Okay, so we got that. So we got the defanged version of this, and then we got the URL domain date that was first submitted to VirusTotal. So let's move on to the next question here. It's kind of an obvious question. Which known service was the domain trying to impersonate? And that would be the service PayPal. And now we can move on to the next piece. So it says, what is the IP address of the malicious domain? All right, so to find the IP address of these guys right here, we can essentially just run the same exact thing. But what we're going to do is we're going to extract a couple of new fields. So I'm going to do an eip.dst for IP destination, and then I'm going to do eip.src for IP source. So I want to extract also those fields for everything that we're going to get here. And then now what we're going to see is there are certain things that are matching for these files, right? So, or for these packets, these queries, this data points. So we have the IP destination is going to be this, and then we have the IP source is going to be this. So for this thing, the IP source address seems to be this piece right here, and it's 757575. So I want to say that it's the 192 that is going to be done in this case. So let's see if it is actually indeed the 192. So if we copy this piece right here, and then we're going to go to CyberChef, we're going to paste it, and we will get this data. And from here, let's see if this is indeed the right data. I think that is the right data. It's not. Okay, so let's see. What's the IP address of the malicious domain name? So that one isn't the right one. So maybe it's the other one. Let me see. Okay, so here is what I found. So I messed around with a few different fields, and DNS.A is a field that has been assigned to the A record, and it's used to map a domain name to an IPv4 address. So when you filter using that, you essentially are filtering for the DNS responses that provide that address associated with a particular domain name. So it's not necessarily the source IP address, which is, interesting, honestly, because I would think that the source IP address would be that individual address. So we got a different address completely for running this. And this was using the DNS.A field that's been extracted from this thing. So I tried a few other fields as well, and I didn't get much data. And it's assuming that there is some kind of A record or a record for the domain name, and this was one of the fields that ended up actually having some kind of a data. There are other fields that I tried that I'm just kind of giving you the shortcut to the thing that actually finally gave you the response. So this is the one that we got as an extra piece of data that potentially could work for us. So let's go over here in not Wireshark. Why do I keep saying that? In CyberChef. We're going to go in CyberChef and we're going to retry this address. Okay, cool. That is the address, the IP address of the malicious domain. That's what it is. So now what we're going to do is we're going to try to find an email address that was used, and then we're going to also do that in defanged format, and that's basically it, the last version of this whole thing. So what is the email address that was used in defanged format? So let's go over here and let's try to run a few other queries to see what we can find here. All right, so for this one, I kind of don't know where I would start. So I need to really just start from the top. So what I'm going to do, I'm just going to read this file. I'll do it in verbose mode so that we actually get everything that we need. And then I'm going to export it to a file. So we actually have like a txt file that we can search through. And then from there, we'll try to create some regular expression patterns to see if there's anything that we can find, really. So first and foremost, we have our text file. So if I just do full capture, let's see if it'll just show anything. Yeah, so it shows me everything that's inside of this thing. And obviously there's a lot of data, because even if we scroll to the very, very top, we're not going to be able to find everything. So we actually have the output into a text format that we can read, so that's great. What we need to do now is we need to create some kind of a pattern that we would be able to use to search through that entire piece. And one of the things that I'm really just adamant about is regular expressions. So I'm going to first read this, and I'm going to see if I can get just the titles, the column names, so to speak, of everything that's inside of this information. So we can do this in a few ways. So let's try the head option. And so we have just the first portion of this, and there's a variety of data, but it's not, it just gives me the first 10 lines. So, okay, so we're actually going to take a completely different approach. I'm just going to use grep to search through this document, because I know for a fact that I can combine regular expressions with grep. I know that this is kind of outside of what they taught us inside of the first few TShark rooms, but I don't know the field name that I'm looking for. That's the thing that kind of like throws me for a loop. I don't know which field name specifically would have the data that we're looking for, which is the ASCII data, which is inside of that data is going to show us the potential email name as like a payload, or maybe the hex data, but I don't know the field name, and I'm ashamed of it, so don't judge me, and I know it sucks and whatever, so I'm kind of doing like a cut around in this case. So what we've done is that we've read this pcap file so far. We've read this pcap file, and we have exported the entire contents of that pcap file inside of this txt file. Now what we can do is we can search for a pattern by doing grep E with a capital E, and capital E essentially is like an extended regular expression, so you can just do really any kind of regular expression that you want to search for something. And the way that I typically just search for things using Regex is that, especially for email, so the way that I would search for emails would be to do something like this. So you do the \W+, and that's any alphanumeric character, and that would be done inside of these closed brackets, these square brackets. And then what we're going to do is we're going to add the literal @ symbol, because that's what we want inside of this to work. And then we're going to go over here, and then we're going to do something similar again, because we don't know what the domain itself is going to be, if it's Gmail, if it's Hotmail, whatever. So we're going to do the same thing. We're going to do \W+, and then we're going to close that. And then what we want is a literal dot. So you would do a plus and then a / and a dot, because a dot is a wildcard character that's inside of regular expressions. So when we want a literal version of it, we do a / to escape. This is beyond the scope of this room. If you don't know what this means, go watch the regular expressions video that's on this channel, so you can learn more a lot about these things. So / dot would give us a literal dot, and then we just need to give ourselves again another pattern to be able to get the .com, .net, so on and so forth. So \W+ again. So it's a very, very simple pattern, and it's a very powerful pattern. And to make sure that this is actually working, what I'm going to do is I'm going to take this whole thing and I'm going to copy it, and I'm going to go to this website, which is a really awesome website, because Regex 101, and you can paste essentially any pattern that you want to search for something. So now in this particular case, I can do this is the email, and then do hank@gmail.com and press enter. And so it doesn't show me the full piece right here because it's missing the .com for me. So I need to be able to find what actually works in here. So the first portion is going to give me the let's see, if I did this without putting it inside the brackets, maybe that'll work. So let me modify this real quick. Okay, so without the square brackets, it works, and it actually pulls the information that we need from it. And now we can turn this into our pattern. So I'm going to copy this pattern, and I'm going to go inside of my terminal that was right here, and I'm going to just paste that pattern without using the brackets. So my bad for the brackets. And we're going to paste that, and we're going to use that as our regular expression, and then we're going to use the full capture txt file as our actual file. And cross fingers, let's press enter, see if anything works. So we got johnny5alive@gmail.com, and then there were a few other versions that could potentially work here, but these are the actual usernames that showed up. So johnny5alive@gmail.com. And now it's time to check to see if that's actually the email address that we're supposed to be finding here. So we will do in defanged format, which is yada 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 at. So I don't know if CyberChef is going to do it, but let's try, see if we can do it inside CyberChef. If not, we'll just do the manual defanging. So if I go over here and let's zoom out and see if they, I don't think they do defang of an email address. They kind of do. So they have that like brackets at the end of it. So it kind of has the defanging of the .com at least at the end. So what they want is yada 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 at this and then .com. So what I'm going to do is I'm going to do this at that, like that. I think that's what they want. Press enter. There you go. That's what it is. Okay. So just to review what we did over here, okay? Just so you understand exactly what just happened. So I'm going to clear the screen. So the first command that we ran was to read the entire pcap file and output it into a specific text file for us, which is this command right here. So TShark read, and then teamwork pcap in verbose mode, and then you just output that into the full capture txt file. That was the first command that we ran. And then from there, I tried to read the actual file, and you saw that there was a lot of data on there. And then I tried to read the first portion of it, but it didn't give me much data to work with. And then I tried to cat and then grep for what I thought would be the AC section that has all that data. And maybe I should have been searching for hexadecimal or HEX, but I didn't do that. So the final thing was using this actual pattern to search through that pcap file to actually find the email. And Regex is one of the most powerful things that you can do, because you just saw what it did. So it read through this entire thing and found for us all the email addresses or anything that would potentially match this kind of a pattern. So if I do this one more time, you'll see that there were actually a couple of other results, right? So it was j@t.b that matches this pattern technically. And then n@m_.gv also matches that pattern technically. But so do these email addresses right here. So this was the way that we were able to extract the email address from that data. And now we actually have the answer, the final answer of this, and we're officially done with this task. So hopefully you hung in there with me towards the end, especially towards the end, because even I was confused and I was trying to figure out how to get that answer, but we got the answer. So I'm very, very glad that you stuck it out with me, and I hope you got a lot of value from this. If you did indeed find value in this channel and this video, I do encourage that you like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out, and especially as we go through the SOC Level 1 pathway and finish it up, because this is the original playlist, and now we're adding a bunch of stuff to that playlist, and there's all these other playlists as well, and then there's the full playlist that we have over here that has all the other type of content in it as well. So there's a lot of content that's available on this channel. As you can see, we're like literally right around the corner to hitting 200 videos, so I'm really excited about that. And of course, drop a comment. So the comment section is also very live, and I do respond to all the comments that come in, and it's one of those things that if I can, I'm going to answer your question. I can't for some reason click on the comment section right now, but if I do see your comment in the comment section, I will answer it in the comment section. If it's a really good comment, I'll make a video in response to your question, and then you'll get credited for it, and it'll be like a nice thing that you'll do for the entire community, because I'm sure other people will find it useful as well. So make sure that you like, subscribe, turn on the notification bell, and of course drop a comment, and yeah, I'll definitely see you hopefully in the comment section. And of course, I got to give a shout out to the Hackaholics Anonymous community, which is the premier YouTube community for security professionals and hackers. This is my baby. This is the passion project that I was hoping that I would get the chance to work on, and it's been really nice. It's been very well received, and we actually have members in here, and the Discord chats are really awesome. So there's a lot of great stuff about this community. There are a lot of perks that are attached to this community. And so if you don't want to watch this little 14-minute video, then if you click on the read more button, you'll be taken to the actual video page, and inside the description are all of the descriptions that are available for this specific membership. And we have 4 different tiers, and each tier gets more perks than the last tier, and it's really powerful. I think it's one of the greatest things that I have created in my life so far, and no BS, I genuinely mean that. I don't say it just to hype it up, but you know, check it out for yourself. And if you do find value from it, I would love to see you in the Discord chats, and I would love to see you on our live streams and everything else that we got going on for our members. But if you don't join right away, bookmark it for the future, so that whenever you are ready, you can find Hackaholics Anonymous and join our community. So we'd love to see you there. Definitely go check that out. And that is it for this video. We are officially wrapped. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I will see you in the next video. Later. Today we're going to go through the second part of the TShark challenge, which is a part of the SOC Level 1 pathway of TryHackMe in the Network Security and Traffic Analysis module. And this is going to be the very last room for the TShark series. So I'm excited about this. We're going to wrap this up and then move on to the next module, which is going to be the endpoint security portion. Alright, so the whole idea here is to just continue on with using TShark for investigations. And on this particular case, it seems like we're just picking up from where we left off in the last challenge. the TShark basics video and the TShark CLI Wireshark features. Those should be viewed first if you haven't gone through those already. A lot of the basic command line options and parameters that we will most likely use in this room are going to be talked about in those various videos. So if you haven't checked those out, definitely go check those out. This is a part of TryHackMe's subscriber portion, so you would need a subscription for this. But if you have Kali Linux installed, or if you want to use it because it's free, it's an open source software, it's an open source platform operating system, you can definitely install it on your computer using something like hypervisor or VirtualBox, anything of that sort. And then from there you can run TShark, or you can just download TShark and run it from your computer as is. So there's a lot of different ways that you can use it and go along with the instructions that we're going to have in our video today. I've already started our virtual machine, so we are going to jump into the basic overview of this challenge, which is very, very basic, very simple. And then we're going to start from our questions. So let's get into it. This is all we get for our scenario. An alert has been triggered. A user came across a poor file index and their curiosity led to problems. That's basically our alert. The data is going to be inside of the directory curiosity pcap file that's inside of our exercise files, and we're going to use TShark and VirusTotal to get our investigation going. If you have not used VirusTotal, it is a very useful tool, and I highly recommend you get very familiar with it. I go to VirusTotal all the time, especially when I get text messages or emails that look suspicious and I don't know exactly what it is. So I'll just copy the link without actually clicking on the link, and I'll come to the URL portion of it and then drop it in here to see if there's anything that'll show up for that link, if it's suspicious or malicious in any way. So very, very useful tool. I think you should be very friendly with it and get used to using it. So let's go to the first question here. All right, so it says investigate the DNS queries, investigate the domains by using VirusTotal. According to VirusTotal, there's a domain marked as malicious and suspicious. What is the name of the malicious suspicious domain? Use it in defang format. And of course, they're probably in the hint, they're just going to say using CyberChef can help you defang it. So that part is all good, and it's pretty much standard procedure. So I'm going to first open this up in my second monitor just to be able to do this in full screen for you, so you get a chance to look at all of the commands and everything that I'm running. And from there, we'll actually do our investigation and hopefully get some nice answers going for this thing. So I'm going to just drag this off camera and off screen, and we're going to proceed as such. All right, so we're going to open our terminal, and we're going to get to the folder that has our exercise file. So that's basically the first portion of this. It should be in our desktop. So we're in the home Ubuntu. We're going to list our desktop. Yeah, there it is. So desktop, and then there is the exercise files. So in here, we should have directory curiosity pcap. And what we're going to do is we're going to just basically read it with TShark real quick. And I want to export it to just a text file that I can kind of refer to over and over and over again. So we're going to do directory, we're going to read that, and then we're just going to do this little symbol right here, and then we're going to export it into curious.txt. And that should take a couple of seconds, and then we'll have the entire red format of this thing inside of the curious.txt. So here it is. When you just cat the file onto the screen, it's obviously a very massive file. There's a lot of data that's inside of it. I used the -v option, capital V, for verbosity, and I just reran it. So that's basically, this is what it looks like. So let me actually clear one more time just so you can see what the full command looks like. And this is the full command. We just added this -v at the very end right here, just so we can get verbose output inside of our curious.txt file. So we just have a lot of data to work with, and it gives us most of the information and all of the details. So as you can see, when you cat through that, there's going to be a lot of information that really is going to be missed because it's just too big of a file, and it's not going to show on our terminal. So what I want to do is, based on what the instructions said, we want to look at all of the DNS portions of this and see what domain names show up, and then we're going to take those domain names to VirusTotal to see which one has been marked as a malicious or suspicious domain name. So first we're going to look at all of the DNS queries. Okay, so here is the DNS output, and I'm going to show you what I used as a command to read this. And essentially the command at the very top is just to cat the file, and then we pipe the output into a grep command and we search for DNS. That's all I did. And we see that we have a variety of different things that show up, including a list of domain names, it seems like, at the bottom right here. So we have, you know, Microsoft Corporation, we have VOMS. This kind of looks a little bit suspicious right here, so I may just check that out. Digicert, digicert.com, and a variety of domain names over here. So I'm gonna just kind of take these things piece by piece and see what I can find on VirusTotal and see if any of these things seem suspicious. I'm definitely going to start with this guy right here. So let's see what we get here. Okay, so that didn't yield anything for me, and it was me essentially just trying to cheat the process a little bit. So one of the ways that we can actually literally just use TShark to search through the file for something that would be of interest to us is by just using the read parameter and then using the capital Y parameter as well, which allows you to search, and then you can just search for anything inside of the file, for example, DNS. And so if we just run this, we'll get a bunch of queries right here, right? So, and you'll see that inside of this, you have all of these, there's a bunch of data for each line, for example, the IP addresses that are associated with it, there's port numbers and various things that are associated with it. And then we'll see that we'll have the domain name at the end right here. So just looking at this, there is a few things that kind of seem fishy. This thing's kind of scrolling out of control here. If I just scroll up a little bit, I will see that we have the jx2bavong.com. Not exactly sure what this is, and it shows up twice over here. We have Bing, we have more Bing, Microsoft, IECV list, Microsoft. There is another piece right here that's an extension for Microsoft as well. So there's a lot of different extensions here to Microsoft, or I want to say subdomain. I think that might be the word. So there are a lot of subdomains for Microsoft, but there is this one domain right here that seems really fishy from the list that we have over here. So, and this wasn't originally on my previous version, my cheating version of this, where I exported it to the text file and I tried to read the text file for the DNS and try to find it that way. So it wasn't there. So let's see if that specific domain actually will be useful for us. So let's run this here and see if this shows up in any way. And it does. Look, okay, so we actually do have some malicious malware results that came in from our people over here at VirusTotal. So now what we want to do is we want to defang this. So we're going to go to CyberChef and we're going to just drop it in our input, and then from the input we're going to add a recipe to it to defang the URL, which is one of the more popular things that are available. You just drop that in here, the defang URL piece, and then from there you'll see that immediately at the bottom right here it's actually defanged, which means basically that it just has that brackets around the dot so that it's not clickable, and that is going to be the URL. So maybe they'll accept this, maybe they require that we do the HTTP version, but I feel like that should work. Okay, cool, that does work. So that was our first question answered. That is the domain name in defanged format. All right, going to the second question here. The question is, what is the total number of HTTP requests that are sent to the malicious domain? And in order for this to work, we need to use a specific field that shows us essentially the URL or URI that has been found inside of that log file, inside of that pcap file, and see what domain names show up. And then from there, we're going to have to search through all of those results for our specific domain name, because it's going to show every domain name. And then we're going to search for our specific domain name. And then once we have the searches that show our results, we're going to then count the number of the results that show up onto the screen, so we actually have a number for it. So first we're gonna clear the screen right here just to make it nice and clean. And from here, the specific request that we're looking for is the HTTP request full URI. And this is a field that shows up inside of this pcap file in multiple instances. And then for that field, there is a variety of values. So the original query looks like this, right? So we're gonna read the file, and this is essentially what we're gonna do the entire time that we go through this exercise. And then we're gonna look at the fields in text format. That's what the capital T does. And then we're going to extract something from all of those fields, which is the http.request.full_URI. And then what we want to do is we just want to remove all of the blank spaces. That's what awk_nf does. I don't know what it stands for actually. I just know that that specific parameter, that specific command is going to remove all of the blank entries, and it's just going to show us the ones that actually have some kind of a value. So if I run this, I should get a bunch of results. And so we see it right here, right? So we have the HTTP version where it has the actual domain with some kind of extension at the end of it. And then we have another one down here as well. So let's see what other types of results that we get out of this. That seems to be it, really. It's just a HTTP version with various extensions at the end of it. So technically, I could create some kind of a grep format into this that will search for this with any extension at the end of it, right? So it would be a regular expression pattern, essentially, that would give us anything at the end of it. And we can just pipe it into the results that we have over here. So this is what that command specifically is going to look like in this case. So we're going to start the same way. So we'll have the same thing here, and I'm just going to click up so it actually has all of my previous entries. So I have all of these things. I have the T fields, HTTP request full, all that stuff, the awk_nf, all that stuff is still the same. The one thing that we're going to do is we're going to add a few pieces to it. So first we're going to sort it recursively, just to make sure that everything's organized. And then we're going to grep through all of those results for our specific pattern, which is in this case going to be, so let me see if this is actually going to work the way that I think it will. I'm going to test it out, and if it works, I'll let you know. But I'm going to do a few trial and error pieces, and then I'll give you the actual result. Okay, cool. So that actually did work, and that was the pattern that I put in place, where essentially it gave me the domain that we have with an asterisk at the end of it, just to provide a wildcard for everything else that shows up here. So that pattern actually did work, and now what I want to do is I just want to count the number of lines that we have here, so I don't have to manually count it, because sometimes it's not going to be just a few that you can count manually right here. So I'm just going to do NL for numbering of the line. And then we have 14 results. So let's cross our fingers and let's see if 14 is actually the answer. And it is. So 14 is the right answer in this particular case. And that makes me very happy that that was the thing. So just to give you a review of what worked. So we read the file. That was all good. We do a T field, so capital T fields. And what that does is that it gets all of our fields for us in text format so that we can search through all of them using this specific field name. So the http.request.full_URI. And then the awk_nf removes all of the empty fields, sort R sorts it for us. And then from here, we just grep through the list that we had. So I had to see whether or not it showed up in the previous version, and we do see that it shows up in a lot of different ways. It just has a bunch of extensions, and we want to see how many different times this domain actually shows up. So in order to make that happen, you just create a grep command, a search command, and you put inside of your quotations the domain name / still is included in it, and then that asterisk at the very end acts as a wildcard character. So anything that was shown or anything that was searched for in addition to that main domain is also going to show up. And then the NL just numbers the lines. So it just counts the lines for you. So it'll be 1 to 14. And then so we have 14 instances. There is a version of this that you can do that if you go over here before you do the grep and you do the sort R, and before all of these things actually right here, I can also do a capital E where I extract the field itself. And what we're looking for is header, and we're going to do yes as in true, and then we're going to run that, and it's going to actually, oh, it didn't work. So I think I may have used the incorrect parameter. Let me double check and make sure, because there's a way that you can run this and it'll actually give you the header name, meaning the name of the field that we've extracted. So let me just double check that real quick. No, this actually is the right option. I did type it out correctly. There's nothing missing in this particular case. For some reason, it's just not showing the header. Basically, what it would do is that it would just print this at the top right here. So it would show this specific thing above all of these answers, just to show you that this is what you're looking at, is this specific, HTTP request full URI. That is what it would show you. But apart from that, it's all good. I wonder maybe if I didn't have it including with the grep command. So let's just try that real quick before we move on. It's not important. This part doesn't really, it's not that big of a deal, but I am curious as to whether or not it is working properly. And I actually, you know what? I have it right here. It literally shows, I think it's showing me at the bottom right here. So if I didn't do sort R and I just did sort, maybe it'll show up at the top. So let's see. Yeah, it does show up at the top. Okay, so the two things was that number one, we can't grep it and expect it to show, because grep, you're looking for a specific result. So obviously the header portion wouldn't show in there. And then when you do sort R, it actually reverses the output for you, and it shows everything at the bottom right here, which is kind of odd, honestly. But that's neither here nor there. This is just extra kind of filler, so to speak. I may just even completely cut this out. If I don't and you're actually hearing this, then I decided to leave it in, but we'll see how I feel during the edit. Apart from that, we actually got the answer that we were looking for, so we can now move on to the next question here. All right, so the question here is basically asking for the IP address associated with the malicious domain. And there is an IP address associated with this thing, and we actually had it originally with our DNS search command. So I'm just going to do that command one more time for us to be able to find the IP address associated with this thing. And it was TShark read. I totally forgot the name of the file. So what's the name of the file? Directory curiosity. Okay, there we go. Let's clear the screen. So here we go, TShark read directory curiosity, and we're gonna search for DNS inside of it. And that's basically all it is. And at the very, very top, we see right here, there's an IP address at the end of this domain name. When you see right here, there's an actual A directory, or not an A directory, a record. There we go, that's what it's called, an A record for this. And that is the IP address that's been assigned to this. And there is nothing else that shows up in this regard. So I'm going to copy this and I'm going to defang this IP address, and then we're going to see if this is indeed the right answer. And then in order to do that, we're going to do defang IP address, and we're going to drop them. And both of these things could be active at the same time, and it'll still work. As you can see, it does defang it for you at the bottom right here. So I'm going to go here. We're going to take this thing, copy it, and then we're going to go and drop it here. And there you go. That is the right address, the IP address associated with this malicious domain right here. Okay, cool. So let us move on to the next question here. What is the server info of the suspicious domain? So we are now looking for another field that's unique to pcap files in Wireshark that's going to give us the server info, and that's going to be the http.server field. So very similar to what we did previously in the last search, not the one that we found the IP address right here, but the one right before this, where we were just looking for that URI, right? So again, we're just going to read. Let me clear it up. Let's zoom in a little bit more just to make it a little bit easier to see. So we're going to first read the directory pcap file, and then from here we're going to get the fields in text format, and this requires that you extract something. So you're going to do lowercase e, and then we're extracting the http.server And then we just want to remove all of the empty files, or the empty fields, excuse me. And so then we have this information here. So we have the Apache 2211, Kestrel, and then Apache, and then ECS, and then Apache. So I want to say it's the Apache 2211 that they're looking for. Let's see if that is indeed the case here. If I were to be a betting man, I would say that this is the result that we're looking for. So I'm going to copy this and see if that is indeed the answer that they're looking for. It seems like it would be based on the format that they gave us. But yeah, that is it. Server info of the suspicious domain is Apache. I mean, there's literally only a handful of results that are over here. So that one was a little bit easy to kind of determine. But there are ways that we could also just search for, if it's a gigantic file, you can search for it using the T fields and then extracting other fields and just lining them up next to each other to make sure that you are indeed actually getting the information that you're looking for, and it matches up with the data that you're trying to pull here. So I'm gonna test a version of that to see if we can actually line these things up next to each other and maybe pull both of the data points next to each other so that you can see how it worked out. So let's do that. And then we're just going to do the URI, right? So it was originally we had the HTTP server, and then the previous search that we did was for the URIs that would get us the domain names that were matched up next to each other. So if we just extracted that field as well, hopefully, I'm not going to make any promises, but hopefully it'll actually work. So let's see. Oh, I had too many versions of that. That's where that error came in. I already did the -e and I did an empty -e. So let's do 1e. Okay, and then we have the results here. And then now we can try to pull that information because it's on here. Oh yeah, right here. So you see the JavaBong whatever whatever, and then you have Apache da 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 da, and then JavaBong whatever, and then you have Apache da 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 da. So these are the actual fields associated with these domains. And then of course DigiCert also has Apache or whatever, but in this particular case what we're looking for is for this malicious domain name, what was the server, and we do have Apache 2.2.11, etc., etc. So that's how you can make sure that it actually lines up, and that is what it is. You just pull that extra field, the URI field that would show you the domain name, and then right under that or right next to that, if it was like spread out wider, it would actually show you this thing right next to it, but it was one after another. So we got the result that we were looking for. Excellent. So now what we're going to do is we're going to follow a stream. And this is something, again, that they taught us in the CLI Wireshark room for TShark. And following those streams is actually very simple. It's not a big deal. So what we're going to do is we're going to follow the first TCP stream in ASCII format. All right, to follow the first TCP stream in ASCII, we are literally going to use the follow parameter, and then you're going to choose TCP, ASCII, so on and so forth. So I'm just going to read that for you, or excuse me, I'm going to type that out for you so you can just see how it plays out. And then we're going to look at the number of the listed files that are available to us. So let's zoom in back to our terminal here. And what you're going to see is honestly, it's super simple. Like once you get a hang of these patterns, you'll see that it's very, very simple. So again, we're going to read it. We're going to do -z because we want to use the statistics, and then we're going to do follow TCP ASCII, all of that, and then we're going to do 1 for the first one, and then we're going to run it in quiet mode because we don't want to see all of the output. We just want to get the data that we want. So we're going to press enter, and it's going to bring everything onto the section. And so the question is what is the number of the listed files? Okay, this is not the first file. I think this is actually the second one because it starts at 0. So I think I actually mispresented that, which is going to be 0 right here. And then we're going to read that. And this should give us a different output to see if we can count the number of the files. And yeah, so this actually has a lot of different output that we can see over here. So we have the HTML of the page, index, and then you start seeing these various files that are sprinkled on through here. So you have the 123.php. There should be other files in here as well. So let's try to see what other files we can find. You have the vlauto.exe, and then you have the vlauto.php. And those are, as far as I can tell, the only files that exist on this specific packet that has been captured. And there's nothing else that is of relevance to us, of interest to us. So 3 is the answer. Excellent. So the first TCP stream is 0. It's not actually the number 1. It's very similar to the index positions that are available in most coding languages, where it starts at 0, and then 0 would be 1, and then 1 would be 2 technically, and then 2 is 3, so on and so forth. So the first one is 0. Just keep that in mind. Apart from that, everything else was perfectly fine. So moving on to the question, what is the file name of the first file, which is that first one is the PHP file. So what was it was like 123, right? Yeah, 123.php. So to defang it, you just need to do the square bracket dot and then another square bracket to close it. And that's how you defang a file name. Basically, you're just putting these brackets around anything that would be, you know, a / technically, or a dot or something like that. That's kind of what defanging is. So 123.php is the defanged version of that file name. So now, export all the HTTP traffic objects. What's the name of the downloaded executable file? And enter it in a defanged format. And I mean, technically, you could actually see it right here. There's literally one executable file, which is the vlauto.exe. But just to show you how to export files and export objects, I'm going to run this, and I want you to see how this whole thing works. So let's zoom in again here. And what you're going to do is you're going to essentially, it's very similar to everything else that we've done so far. But you're just going to use a command that is called -- export objects. That's it. And then in this case, what we're looking for is the HTTP objects, because this is technically an HTTP page, HTTP file. And then we need to give it the location of where it needs to be. So I'm going to do the /dot because I want it to be in the same directory that we're in. And I hope that actually works. I'm not sure if that's going to work. Previously, we had to declare the entire path of where it's supposed to be. So we're going to run that, see if that actually works. It says you don't have permission to write . So let me see if it actually gives me anything. It doesn't. So what I'm going to do is I'm going to do it again, except now I'm going to give it the full path of what we're looking for, and let's see if that actually works. Okay, I think it worked. So let's clear this, let's list this. We do now have a directory called export. So let's go to the export directory, and oh my god, we have all of these files. Okay, there are not that many. Okay, oof, that freaked me out for a second. Okay, and then we can see that, you know, it exported all the files associated with it, and then from there we see that there's the executable file right here, vlauto.exe, and that is actually the only executable file that exists for this specific pcap file. So we can now take this executable file and then defang it, and then that would be our answer. So it would be vlauto and then do it like this, and then exe. And that is the file name. There we go. Excellent. So what is the SHA value of the malicious file, the SHA-256 value? And that, assuming that these files have all been exported to what we have over here, what I'm going to do is I'm just going to run the SHA-256 sum, which is a very basic command that just gives you the SHA value of anything. And then we'll do vlauto.exe. And then we'll run that, and there's the SHA value. So this is just as simple as running the sum command, and that works for, you know, MD5 sum, it works for SHA-1, so on and so forth. So that one's very easy to grab, and as long as you're inside of the directory of the file itself, or you use the full path to the file. So it would, if I was in the home directory, I would do /desktop, yada yada yada, export /VLauto.exe, and then I would use that combined with the SHA-256, and it will still give me the results. So there's that, and then we're gonna run that. Oh, whoops, it did not copy what I wanted it to copy. So let's take this piece one more time and let's copy it. There it is. And there we go. Okay, cool. And now we're gonna search the value on VirusTotal. What is the PEID packer value? So search for this specific SHA value on VirusTotal and then get the PEID packer value. So we're gonna go to VirusTotal, and it's actually very easy. You just go back to the home page. It seems like I'm zoomed out. So let me just zoom back into my screen because this looks so weird right now. There we go, 100, no, and also 110%. What's happening? Did I do it incorrectly? Oh, I see, that's what it was. I was like, why is it so grainy? Anyways, we're gonna go back to VirusTotal, and then we're gonna go to search right here. And then in search, you can literally just drop in the URL, IP address, domain, or file hash. And so I already have this giant file hash. I'm gonna search for it, and then it gives me all of this data. So what I want is the PEID. So I go to details right here, and then under details, you're gonna have a lot of magical information. And then right here, PEID packer is .NET executable. And I wonder, is that what they're asking? Yeah, the PEID packer. So it's actually a .NET executable. That's what it is. And there you go, just like that, we got the last PEID value of that SHA-256. And finally, we want the last line sandbox flag for the same exact SHA-256. So what does the last line sandbox flag this as? So let's go and try to find that data. All right, so instead of scrolling through all of this, I can literally just do a Control F and do last line and sandbox, last line sandbox. All right, under the behavior tab, we now have a few instances showing of last line. And so I have last line right here, Microsoft sysinternals. What is the question they're asking here? What is it flagged as? So let's see. I have this right here, and display group sandbox reports here. We have last line, oh, here we go. Last line flags this file as a malware Trojan. And that should be our last question. Voila, we are officially done with this lab. Excellent, we are done. That was a fairly quick lab, and we have plenty more like that in store already in the scheduled content. And then of course, if you just want to find more information like this, you can go scroll through our channel, and there's a lot of videos. There's currently 199, but then there's 2 that are scheduled, and by the time that you see this video, we're definitely going to be over 200, because this is going to be scheduled after, I think, like there's 2 or 3 more pieces that are recorded that's going to come out. So it's going to be an exciting series of videos that are going to come out, and this is all under SOC Level 1 because they updated the SOC Level 1 pathway, so everything is over here. This is the original playlist for SOC Level 1, and all of these videos were shot months ago, like 8 months ago is when these things started. And from here, we just got a notice that this was updated and there's a lot of new content that was added. So now we're just finishing it up to make sure that we have a complete playlist for SOC Level 1 from TryHackMe. So you can find that, and you can find everything else that's available. SOC Level 2, I have to put the playlist on the homepage right here, but if you actually go under playlists, we already have the SOC Level 2 playlist that's out. There's 25 videos on the SOC Level 2 playlist, and there's a lot of other playlists and everything else that's going on. So you can definitely see what is available to you and take advantage of it. And to get notified of videos like this, or to get any other type of video, or get some videos made for your comments and everything that comes in, make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. And again, if you actually drop a comment, and if you have a good question that's a deep question and it requires a long answer, I'll create a video in response to your question, and then that'll help you, of course, but it'll also help the rest of the community as well. So make sure that you like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out. And if you have not done so already, I would recommend that you check out the Hackaholics Anonymous membership community. This is going to be the premier YouTube community for security professionals and hackers, and there are a lot of perks that are attached to this community. So if you haven't checked it out already, I would highly recommend you watch this video. It's a 14-minute video, but if you don't want to read it or if you don't want to watch it and you just want to go through the contents of it and see what's available to you as a perk, if you go here under the description, you'll see that we have all the various tiers and all the benefits that are attached to each tier, like Python downloads and bug bounties and exclusive content and Discord chats and discounted merchandise and yada 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 yada. There's a lot of stuff that's attached to the Hackaholics Anonymous community, and I would very much love to see you there. I think it's going to be beneficial for anyone who joins it, because it is my mission to make sure that it is the best group for hackers and security professionals that's on YouTube. But if you don't join it right now, just bookmark it for the future, because the channel itself has a lot of great content in it. So Hackaholics Anonymous is available for you if you want to really take that next path and get to the next level. If you just want to be a supporter, there's also a supporter tier that's super low end, and it would be really, really nice to have you as a supporter. It would mean a lot to me. But if you want all the perks and everything else that's attached, definitely check out the more advanced tiers just so you can see what's available to you. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I will see you in the next video later.